صباح الخير جميعا، نرحب بجميع الحضور. السلام عليكم ورحمة الله وبركاته. نبدأ الجلسة اليوم. صراحة ستكون باللغة الإنجليزية، ولكن سنقوم بترجمة بعض النقاط المهمة. وهناك خاصية من يوتيوب لإضافة ترجمة النص باللغة العربية. يمكن تفعيل ذلك من خلال الذهاب إلى قناتنا على يوتيوب. سنرسل لكم رابط هنا في الشات. وإن كنتم تريدون معرفة طرح أي سؤال باللغة العربية فيمكنكم ذلك. أما النصف الثاني من الجلسة طبعا هذا فقط من النصف الأول من اليوم، والذي سوف يستمر لحوالي الساعة 12:30 بتوقيت مكة المكرمة. أما الجزء الثاني والذي يبدأ في الساعة الثانية بعد الظهر فسيكون باللغة العربية مثل البارحة إن شاء الله. يعني فقط النصف الأول سيكون باللغة الإنجليزية، وذلك بسبب أن المواضيع هي أكثر مواضيع لم نستطع أن نجد متحدثين باللغة العربية لهذه المواضيع، ولكنها مهمة جدا، ونود أيضا أن تكون متضمنة هنا في جلستنا اليوم. نعطي فقط دقيقتين حتى ينضم إلينا عدد أكبر من الحضور، في رجاء إرسال بخاصية الشات إن كان لديكم أي أسئلة. سوف أكون سعيدا بالإجابة عليها، بالإضافة إلى زميلتي ملاك والتي تقوم بالمتابعة معكم في خاصية الشات. We start just in 1-2 minutes, giving a chance for people to join, and so we could have most of the people with us here on Zoom. This event then is also broadcasted live on social media. We will also bring some questions from there for people that ask their questions on social media, and we'll be discussing that in the Q&A panel. طبعا الأشخاص الموجودين معنا يمكن على السوشيال ميديا يمكنكم طرح أسئلتكم باللغة العربية أو بالإنجليزية كتعليق أسفل الفيديو، وسوف نقوم بطرح هذا السؤال خلال جلسة اليوم. نعطي عدة أتوقع ثواني حتى نبدأ. أود أن أبدأ بطرح بعض الأسئلة المهمة لدينا هنا. أوكي، أتوقع أصبحنا جاهزين. إذن هذا القسم من اليوم للذين انضموا إلينا الآن سوف يكون باللغة الإنجليزية. لو لديكم أي أسئلة يمكنكم طرح ذلك، سوف أقوم بترجمتها. I wish to welcome you all to this Energy Storage and Solar Balance of System conference for the MENA. Let's say this is a 2 days conference. We had a very successful first day yesterday. We covered many topics speaking about the impact of integrating renewables to the energy grid. And we spoke later in the second half of the day about the energy storage solutions, where we had a deep dive for technology of battery energy storage solutions and the applications and the economical models for different applications of energy storage. On the second day today, we wish to continue to focus on the microgrids and off-grid applications and look into these smaller projects that are more relevant in the CNI world and for communities and so on. And that's definitely a very, very important topic, especially in the Middle Eastern region and the Northern African region, because we have a lot of remote areas, a lot of oases, a lot of industrial or commercial entities that are not connected to the electricity grid. Or if connected to the electricity grid, then they have the potential to have stable, better connection to electricity, or to save costs as we go forward. We know that the prices of electricity are always increasing, and it's always good to hedge against the electricity prices of the future. In this part of the day, we'll be talking mostly about the advanced technologies, how to utilize big data, how to utilize artificial intelligence for our energy applications. And we will talk about some robotic solutions, in addition to advanced technologies to test the solar and energy storage equipment that are used on the site for our projects. It's very important that we we don't just accept test certificates, but especially for bigger projects, we would go and run custom, let's say, tests that are happening in many countries in this region, especially that we have today guests from GCC Lab, we have guests from QEERI, from the Qatar Environment and Energy Research Institute, and both are doing a lot of localized tests for solar equipment, and we will hear about that later on as we move forward. I'm very happy to have today an amazing lineup of speakers with very high expertise in their domains, and I'm happy that they get the chance today to join us and share their knowledge with us. We will be starting this session with Mr. Hugo Gaillard from Siraj Power, who will be covering the big data and off-grid solar technology to maximize the asset return. For the next part, we will have Mr. Munseb Mohammed from the GCC Lab, and he will speak about operational reliability, performance, and lifetime evaluations of PV and battery inverters. And then we will move to Dr. Raed Bkayrat, who will be talking to us about utilizing robotic solutions for cleaning PV panels, and with the focus on the dry cleaning. And then we will have Mr. Krunal Patel from ACWA Power, who will be speaking about grid forming inverter technologies, talking about the future requirements and the importance of this technology for the microgrids. And then we'll be hosting Dr. Antonio Sanfilippo from Qatar Environmental Energy Research Institute, who will be talking about artificial intelligence in the energy management domain. With all of these topics, I think we will have a much better understanding how to utilize advanced technologies, data, AI, robotics, advanced techniques in testing and testing equipment in order to optimize our microgrid and off-grid projects. That's all from my side for an introduction. I'm very happy to have you all on board. If you have any questions, please send them in the Q&A section. So if you have questions to the panelists, please send them to the Q&A section in Zoom, not in the chat section, but in Q&A. Very important. I know I said it multiple times. This helps us to capture your questions. If you send them in the chat, we might miss them among the hundreds of the messages that come up in the chat section. Send them in the Q&A section, and we'll make sure that after the last session, we will have approximately 30 minutes to answer all of your questions as they come. So without further ado, I wish to welcome again Mr. Hugo Gaillard from Siraj Power to start and talk about big data and off-grid solar. Welcome on board. Hugo, you can share your screen. Hello, yeah, I can hear you. You can share your screen, and you have 20 minutes, please, to go through the session.
All right, let me know as soon as my screen is visible.
Perfect, yeah, that's in full screen.
All right, and am I audible?
Yes.
All right, thank you very much, Moni, for the introduction. Just a few words about myself. So my name is Hugo Gaillard. I've been heading the solutions department at Siraj Power for about 2.5 years. And today I will be giving a short presentation on how big data and artificial intelligence can be used in order to maximize the asset return for off-grid hybrid assets. So, okay, right. So just a few words about Siraj Power. Siraj Power was founded in 2015 and is currently the #1 provider of financed distributed solar solution in the Middle East, with a portfolio of above 100 megawatt peak of distributed assets over almost 200 facilities, some of them being on-grid, but also some of them being off-grid. Each year, we bring savings of CO2 emissions of above 80,000 metric tons. And this is, although Siraj Power was founded in Dubai, now Siraj Power is growing and has grown its footprint to several countries in the GCC, with a newly opened offices in Saudi Arabia and Bahrain, with recently a first project of rooftop solar signed in Bahrain. And we are also exploring opportunities in Oman. So just to give a simple understanding of Siraj Power's value proposition. So the common denominator in our different offerings is to meet the sustainability goals of our clients, while still ensuring cost savings, right? And also by the same way to increase the energy independence of our clients. And this applies to different three, let's say, verticals. The first and the historical one being distributed solar. So standard rooftop and carport solar farms for CNI applications. Those solutions come as fully financed on a pay-as-you-go model, right? So similar to a power purchase agreement. And this model is basically applied across our three verticals, so distributed solar, which I mentioned, but also hybrid power and energy delivery. So today we will focus more on the hybrid power, which is basically relying on hybrid microgrids, combining solar power and diesel generators. We also add some energy storage at site in order to be able to increase the penetration of renewables. And these solutions come fully financed in the sense that ultimately our clients just need to pay for whatever energy they consume. And Siraj Power keeps full ownership of the assets and operates the asset and bears the entire risk. So the applications range from remote camps, construction sites, to military facilities or islands. So we have a very broad range of applications, and all those applications, as mentioned here, are all off-grid and were initially run solely on diesel generators. So running on diesel generators come with a few challenges. So the first challenge that usually can be observed is that the efficiency of power generation is quite poor. This is mainly due to oversized diesel generators, which also do not reflect the seasonality of the loads. So depending on the different applications, we will see a moderate or a high seasonality in the load demand. However, usually, so diesel power plants are usually first oversized, but sized just for the maximum peak load, which means that we would have an overcapacity, and this is more even true in winter. So this is the first aspect, which means that running an oversized diesel generator will result in a poor fuel efficiency. Secondly, diesel generators, of course, come with high cost and hassle of maintenance and operations. The third challenge that frequently occurs is the blackouts due to genset failures. And of course, finally, the main challenge are the costs implied by running on diesel generator. And that's not only rental costs, which of course are substantial, but the main share of the cost of energy will come from the diesel costs. And with our fully financed solutions, we aim to address all these challenges at once. So the value proposition is described here. Siraj Power basically proposes a solution without any capital investment from our client, proposes a tariff which turns out to be lower than the initial baseline cost of running on diesel generators. Our solutions are modular, which allow us to be quite agile and adjust the sizing of our power plants depending on the seasonality, depending on the project lifetime, and or sometimes due to relocation of the facilities. And so this comes at a cost-effective tariff. The solution is more reliable and comes with a commitment from Siraj Power to reach a very high uptime. And finally, this of course is in line with the net zero objectives of our clients, with some of our projects where we've reached more than 90% of penetration of renewables. Now, as Siraj Power is a fully integrated player and offers an energy as a service proposition, it's key here to understand that we bear the entire risk. Okay, so from the project development and financing to the engineering, to the construction, but also to the operation and the maintenance. And basically, contrary to the situation that we have in our historical business, which was distributed on-grid solar, in the case of off-grid, there's obviously no grid that we can use in order to inject the excess power generated by solar. So it is critical that our assets are sized in the proper way at any period of time throughout the project lifetime. So obviously that means that we need to have a clear understanding of the load demand of our clients. So before starting even a project, but also throughout the lifetime of the project. And the risk of having an accurate understanding of the load is illustrated here on this graph. So here we can see in the orange line is the load demand of an off-grid site. The blue line is going to be the available solar PV. As you can see, the green area is the energy which is supplied by the battery, and the dark orange area is the energy which is generated by solar and used to charge the battery. Then finally, the light orange area is the energy discharged from the battery and utilized to supply the load. Now, as you can see here, in this case, a around 3 p.m., just before 3 p.m., the battery was fully charged, which resulted in a significant amount of solar being basically curtailed, so wasted. This is this area in red. So, and this, of course, because this is energy which is available, but which is not sold to our clients. This is obviously an inefficiency in paying back our assets and maximizing the return. So basically, it is key to size the solar properly, so to make sure it is not oversized. So either solar is oversized, it's also important to size the energy storage in the energy storage the right way. It's actually even more true for the energy storage, because energy storage does not produce energy, just allows you to shift energy from day to night, basically. So we want to be extremely accurate in forecasting the loads, even before starting a project, so we know how to properly size the system. But this is also true throughout the duration of the project, because no matter how accurate the load forecast will be, the load might still evolve, where the client will decide to add or remove some appliances. So we need to be quite agile, and we need to constantly run load forecasts in order to be proactive and not reactive. So we want to be able to know if we should deploy more solar, or if we should decommission some solar, maybe shift it to another asset. And basically, what is key is to have a portfolio view and to be able to ensure that the right system size is allocated at the right site in order to maximize the return of the entire portfolio. And in order to be able to do so, we need to have very robust load demand forecast models. So this is the first lever, if you want, to maximize the return of our assets. Now, the second lever is to ensure that the remainder of the power is generated at an optimal fuel efficiency. As we mentioned before, we are using hybrid solutions, so which means that part of the energy mix comes from solar, but the remaining part will come from fossil fuels. Now, it is key that this remainder is generated at an optimal fuel efficiency. And as you can see here on this typical diesel generator fuel efficiency curve, a diesel generator will run efficiently whenever its loading is, let's say, above 40%. So in a window, what we call the target operating window, where we want to operate the generators. Which means that if a generator at a certain point of time is oversized compared to the load demand, let's say the net load demand, so the load demand minus whatever is provided by solar or by the battery, we need to make sure that at this point of time, the loading of the genset is not too low. And for that, we use different sizes of generators. So contrary to what we commonly see as a baseline, where we would have a set of similar gensets, we try to keep different generator size in order to be able to switch on and off the right generator at the right moment. So it is also critical that we understand what the net load will be. So that is with a strong load forecast and also a strong solar availability forecast, in order to understand which generator should be switched on and off and at which time of the day. So in order to achieve our two objectives that we just mentioned, we need a very accurate and robust load prediction tool. Okay, and this is why we are currently implementing some algorithms which are based on machine learning in order to predict the customer load over a full year. Okay, this will allow us to understand what is the seasonality of the load, which allow us to be proactive and maybe to have a different system sizing for winter and for summer. But we actually want to understand it also within a day. So we want to understand if the load demand will be higher during daytime, which actually means that it will be easier to reach a higher penetration because it will be aligned with solar availability. Or to the contrary, if we have maybe some peaks in the evening or at night, which means that we will need to have more storage at site, for example. That allows us to size the system properly. Now, we also need to be able to set what we call the operating philosophy. So the operating philosophy is how we operate the microgrid at an intraday scale. So basically, we have an energy management system at site, which will take the decisions on whether to charge the battery, when to discharge the battery, when to switch on and off generators, and which one. And in order to take those decisions, we need to define some operating set points. And the whole idea is to have a digital twin of our hybrid power plant that will be able to simulate the behavior over the next 24 or 48 hours, to be able to change those set points if necessary based on the load prediction. So this is a second module that we're currently developing. The third module, what we call here the holistic solver, it is more used at an earlier stage in order to compute the right tariff for our projects. So as we mentioned earlier, we already do some forecasts before entering into an agreement with our clients, and we need to find the right tariff, a tariff that will ensure savings for our customers, but of course that will maximize the returns of our assets. And the right tariff will depend on a lot of different parameters. It will depend, of course, of the load demand itself. It will also depend on the diesel cost, because we offer a tariff for the energy, no matter which source is used. Okay, so we take basically the fuel risk. So we need to understand precisely what the fuel cost will be, what the fuel efficiency that we will be running at, and we want to be able also to, as I said, to reshuffle the power equipment within our portfolio. So each time we want to take a strategic decision, we need to run a solver at portfolio level, which rely on the first two modules, the load prediction and the virtual operator, but that also take into account, let's say, exogenous and macroeconomic factors in order to be able to take the right decision. And finally, the fourth module will be an early diagnosis tool, which will allow us, that applies mainly for energy storage, but that will allow us, based on the observed performance and based on an extensive data set across our different energy storage system across our portfolio, to be able to detect some abnormal behavior in the energy storage, to enforce the warranties, for example, before our energy storage systems shut down, and again, in order to be able to claim the warranty, or to do some preventive maintenance, to anticipate on the preventive maintenance, in order ultimately to maximize our returns. Now,
thank you. I hope if you can wrap up in 1 minute, please. Yeah.
It's my last slide.
Thank you.
Right. So in order to do so, we keep full ownership of our data. We keep ownership of our database of our cloud. We have an extensive set of sensors, of IoT devices. We generate more than 500,000 data points every day. And we've implemented some automated alarming and reporting, which allows us to take the right decision in order to maximize the return of our off-grid assets. And we will use all this data we've been collecting over the last 2 years in order to train as best as possible the algorithm that I've just presented earlier. And that's it, right on time.
Thank you very much, Hugo. Very impressive to see all of that work happening actually in-house within Siraj Power. And definitely this triggered also a couple of questions that we have so far. And I have also a couple of questions in mind because it's a very interesting topic, since it's not very common in the industry to gather all of that data and to analyze it all, let's say, in one bulk of, let's say, big data in order to train the machine in the end of the day. We'll get back into that in the Q&A section. Thank you very much, Hugo. I appreciate your time. And I'd like to jump quickly to Mr. Munseb Muhammad from the GCC lab, who'll be talking about the operational reliability, performance, and lifetime evaluations of PV and battery inverters. The GCC lab, one of the leading labs in the region, and has done a lot of work testing solar equipment, and we'll be very happy to have you, Mr. Munseb, with us today.
Assalamu alaikum, ladies and gentlemen. Am I audible?
Yes, you're audible.
And you can see my screen, right?
Yeah.
Okay. I welcome you all on behalf of the Solarabic and the GCC Labs, Gulf Renewable Labs. Just a short introduction about myself. I'm Engineer Paja Munseb. Currently, I'm the Senior Photovoltaic Consultant for the Gulf Renewable Labs. I have more than 12 years of experience in solar industry, out of which 7 years is based upon working with the photovoltaic manufacturers and inverter manufacturers. So today, the topic of my presentation would be operational reliability, performance, and lifetime evaluation of photovoltaic and battery inverters. Just a quick rundown about the indexes of my presentation. So Gulf Renewable Labs is basically a joint venture company between GCC Labs and UL Solutions. We are based in Dammam, Saudi Arabia. Alhamdulillah, we are the most advanced renewable center in the MENA region. We are offering world-class testing, inspection, commissioning, and consultancy services. Currently, we are able to do more than 60 standard tests within the lab and also in the field testing area in our facility. We have all the accreditations from IEC and the UL standards. We are also having international accreditations from IEC, the EE and ISO and ILAC. We have all seen the technological transformation of the inverters in the past 2 decades. I remember in the past, we used to have cumbersome and heavy inverters which were based on the low frequency and having big transformers in the inside. They were very dumb machines just for the DC to AC conversions. But now, today, we have very advanced power electronic based photovoltaic inverters with a lot of AI integration with AI algorithms, which are doing much more than just converting the DC to the AC on the photovoltaic plants. So within an operational PV plant, the inverters are solely responsible for more than operational functions than any other particular photovoltaic component on any PV plant. So inverters performance is the most important driver for any photovoltaic project's profitability. If an inverter fails, the entire system produces less energy or no energy at all. But maintenance cost compounds the financial losses. But this is a dilemma that yet very few photovoltaic equipment buyers require independent testing that assists the inverter's reliability and performance. So the battery inverter technology, like we all know that the photovoltaic power generation is heavily dependent upon environmental conditions, solar irradiation and temperature. So in order to increase the photovoltaic system's flexibility and to provide a more dispatchable energy. The integration of the battery systems has been considered as a most viable solution. So considering the integration of the battery systems to a photovoltaic system and their point of connection, it is classified into two configurations, the DC coupled configuration and the AC coupled configuration. So in general, any PV battery system has majorly three main components: the PV panels representing the power generation unit, the battery representing the storage unit, and the power conversion electronic units, for example, inverters, converters, and the battery inverter. So depending upon the configuration and the connection of these components, we can drive two configurations of it, like the DC coupled configuration, the AC coupled configuration. The difference in the both configurations is just lies in the point of the connection. So if the battery is connected on a DC link, the DC bus bar, it's called the DC coupled configuration. But if the battery is interconnected on a common point of coupling on the AC side, it is called the AC coupled configuration. So unfortunately, as of today, most of the research has been done on both of the configurations and its comparisons entirely in terms of the economic point of view. The research has always focused on the cost effectiveness of the two configurations, but they have never focused in depth on the lifetime and reliability of the system in both coupled configurations. So system configuration does not only directly influence the operation, but it also impacts the cost, efficiency, lifetime, and consequently the reliability of the photovoltaic battery system. So in terms of the DC coupled configuration, the flexibility for the operation is quite limited because there is only one DC to AC conversion unit, which is your inverter. But in the AC coupled configuration, the operational flexibility is more because you have two DC to AC conversion units like inverter and the battery inverter. When we talk about the PV and the battery system, we normally talk about the self-consumption control strategy. So self-consumption control strategy is the system's energy management strategy that is defining the power flow among the units. It is also directly influencing the loading of the power conversion units, which is very important in order to understand the reliability of any photovoltaic battery system. The key target of the control strategy is in order to maximize the internal power consumption from the battery and the photovoltaics before buying the expensive energy from the grids. So on the right, you see four different graphs. The first graph A is just between the PV power and the load demand. The B explains you the charging and discharging profile over a day period or a period of a day. Explains you about the state of the charge in one-day operation for that particular system. And graph D, you see the coupling stress that is put on in terms of the loading for the DC coupled configuration on the inverter and the AC coupled configuration for the inverter. So in the DC coupled configuration, we normally have two units on the DC-DC interface, the PV converter and the battery converter, and one unit on the DC to AC interface, which is just a photovoltaic inverter. So the PV converter here is a unidirectional DC-DC converter. Its major operation is to step up the photovoltaic power from the PV panels to DC bus bar. Whereas the battery converter here, it is a bidirectional DC-DC converter, and it is operating as a step-up converter during discharging of the batteries and step-down converter for the charging of the batteries. Inverter here is just responsible for the DC to AC conversion from these two power sources and also to sync the AC power to the grid. So the important point here in the DC coupled configuration, the loading for the inverter is based upon the power from the PV converter and the battery converter. Whereas in an AC coupled configuration, the DC-DC interface is the same, but on the DC to AC interface, you have the inverter and the battery inverter. So here, the PV inverter is doing the same job as in the DC coupled configuration, and we have a battery inverter, which is a bidirectional DC-DC converter, working in an inverter mode for discharging and working as a rectifier for charging. So in order to analyze the operational impact on the component reliability, a power converter loading during a typical 1 day of operation is studied. The key target is to investigate the difference in the electrical and the thermal loading of the components in 2 configurations. So on the left, we have the DC coupled configuration. On the right, we have the AC coupled configuration. So we see here in the A that during discharging, the inverter is facing the stress, a loading stress from the PV converter and the battery converter. While discharging, it is under stress from only the PV converter. Whereas in the AC coupled configuration, it is reversely proportional. During discharging, it's the inverter is under the loading stress from the PV converter only. But when discharging of the batteries, it is under the loading stress from the converter and the battery converter. So by examining these configurations, we see that there is no big difference in terms of the loading. But if you can categorize in terms of the charging and discharging of the batteries, there is a big difference in terms of the loading of the power converters. Similarly, then we proceed to the thermal loading of the power converters. In order to understand that, we need to investigate the thermal stress that the power electronic devices within the inverters has to go through during this specific loadings. For example, the IGBTs. So on the right, we have the graphs for the thermal loading of the power devices and DC coupled configuration. And on the right, we have the graphs for the AC coupled configuration. Okay, so what we see here, if we look at the thermal loading of the electrical devices in the PV converter, but between both configurations, it is the same. Similarly, for the battery, it is the same. But when it comes to the inverter, we see a difference of the thermal loading of the electronic devices in DC and AC. Similarly, when we study the junction temperatures between the inverter, converter, and the inverter, we see differences. For example, here on the graph F on the DC coupled configuration and the graph G on the AC coupled configuration, you see that there's a difference of the thermal loading stress on electrical devices. And yet again, in an AC coupled configuration, since we have another conversion unit for the battery conversion, so that is also subject to thermal loading stress between the electrical devices. So this here is the reliability evaluation model in order to judge the reliability of a photovoltaic battery system. So what we do the stress profile interpretation of all the electrical components within the converters under accelerated aging. And then we try to find out the uncertainties. So based on that uncertainties, we develop a lifetime modeling. And from that lifetime modeling, we try to use different research methodologies like well-being distribution in order to judge and evaluate the overall reliability of the PV battery system. This is just a vectorical differentiation of the stress profiles between DC coupled electronic devices within the power converters and the AC coupled power electronic devices and an AC coupled system. So you see, we see certain uncertainties in terms of the stress profiles. These uncertainties are logged together, and then based upon that, we develop unreliability analysis and the curves for the DC coupled configuration and the AC coupled configuration. So after studying the complete scenarios, we find out that in a DC coupled configuration and the AC coupled configuration, the life of the PV converter is almost the same. But for a battery converter, you get additional 1 year of lifetime for a DC coupled configuration. Similarly, for a PV inverter, you get 8 more years in terms of a DC coupled configuration. So overall, the system reliability in terms of the performance and the lifespan is 19 years as compared to 12 years in an AC coupled configuration. So now jumping into understanding of the PV inverter product reliability itself, we have to study the electrical safety, electromagnetic compatibility, the power quality, the grid connection and supporting, and the energy efficiency of the particular inverter itself. So we all know that there are international certifications in order to judge the inverter's quality, for example, for safety, the grid codes, the efficiency testing. But we have a certain limitation with these certifications. These certifications only tell us about the safe operation of the inverter, and most of the certifications assess the safety and interoperability with the grid. They do not cover the extended reliability and the performance test. So in order to judge the extended reliability and the performance test, we have to carry accelerated laboratory test, and we have to do controlled field testing. Other than that, we have developed a program for a third-party testing in order to judge the reliability, performance, and lifetime analysis for a particular inverter under the lab conditions. So what we do the passive test for damp heat, thermal cycling, humidity freeze. We do the thermal performance characterizations. We do the performance testing for the efficiencies, the MPPT, the conversion efficiencies. Then we do the performance testing for the operational window of the inverter's operation. And then we go to the field testing in order to test the ground and arc fault and do the 30 days runtime in order to check the inverter's availability. So even right now, you see a lot of environmental chambers behind me. These environmental chambers are used in two scenarios. One, if your inverter, you place an inverter inside unpowered, and you run the environmental chambers, you test the inverters to different environmental scenarios. It will tell you about So it will tell you a lot about the coating delamination issues, the corrosion issues, the water condensation in the wiring compartments, the decolorization and the melting of external displays and controls, electromechanical fatigue of the solder joints and electrical connections, and the ingress protection of the inverter itself. Here you see a pictorial evidence of a very healthy inverter once it was exposed to environmental test. You could see it's developing the moisture issues within the components and the PCBs. And then if you do the environmental test, when the inverter is connected to a power supply and the load, you can do the testing for full operational temperature range of the inverter. You can test the inverter's inbuilt safety mechanisms that protect the inverters from the high temperatures, and you check the temperature duration factor and actual energy harvest from that particular inverter under high temperatures. So then we go to the operational performance envelope. That kind of the testing is done in the field in order to determine the operational envelope to different AC and the DC input ranges, for example, here and the graph on the top of the right. And then you do the transient response to the changes in the grid voltages and the frequencies. And you do the assessment of the expected product performance to the site-specific conditions. Then you further move down to the field test in order to evaluate the real-time operation and the durability of an inverter when it is exposed to different on-site faults like arc faults, grounding faults. So it tells more about the inverter ability to detect safety issues like arc fault. For example, on the right, you see this inverter got burned. Actually, it failed to protect itself from a ground fault arcing on the side. And then you do the 30 days runtime to establish the inverter availability. This is very important for the financial modeling for any PV developer to know the inverter availability for the noise tripping or shutdown for endless reasons. And then you can check the actual operation of the inverter for anti-island protection. So we need to understand the uncertainties and the risk involved here. So the failure to the inverter components can cause the entire inverter to fail or reduce power functionality. All inverters that are developed on the PV side should pass this test, but however, in practical, this is not the case. So if an individual inverter component operates at an elevated temperature due to poor internal airflow or low design margins, the inverter may intentionally reduce the output power in order to lower the component temperature. But this leads to the reduced energy harvest for our overall system, and it also shortens the lifetime of the inverter itself. So project financial forecast assumes that the inverter will operate effectively and convert the DC to AC energy under the wide range of conditions but some of the products do it in the real time. It is not assumed for all. So all inverters in general, they are expected to operate continuously when the AC voltage and the frequency are within the local code and limits, and the DC energy is available. But testing has shown that in real time for the inverters, they have narrower operational windows than stated on the data sheets, resulting in nauseous trip events and also the derated power output and ultimately lost for a total energy production.
Munseb, if you please can wrap up in a minute, please.
Yes. So the best procurement advice that we as an expert can give you is you know the environment and evaluate the project condition before buying an inverter. Then you have to select the right product considering your DC optimization and the DC loading scenarios for your configurations. And then you have to verify the quality of the selected product by reviewing the factory acceptance test and statistical back testing. And then monitor the product performance in the field test. So the conclusion that we derive from this presentation is that inverters are complex and multifaceted, and they a lot is expected from them by developers, asset owners, and the PV system, the local markets, the regulators, and the grid authorities. They're all eyeing inverters with so much expectations, with so much complexity, and so much at stake. So there are things which can go wrong on the inside and outside of the device. So diligence is not only the paramount of ensuring the long-term reliability and the performance of the inverter, but you need to consider the optional tests for reliability, the performance of the system. So GRL, the Gulf Renewable Labs aim is to provide the critical testing, diligence knowledge that is often missing in today's PV inverters procurement scope. We support buyers in understanding the inverter's critical role in the lifetime of the PV plant, with the hope of improving the quality over time, like we have done so far for the PV modules. So for this, we have all kind of the ISO certifications for the labs and the equipments, and we are working with the major stakeholders in the industry like Ministry of Energy, Saudi Electricity, Aramco, ACWA Power, Baker Hughes, Jinko, DT, NOMAC, and I think that's all from me.
Perfect. Thank you very much, Munseb, for this thorough and comprehensive presentation. I know it's a very big and a very technical topic. It's impossible to cover that in details within 20 minutes, but at least it gives an idea of the amount of work and level of details and type of technology that you work with. That's very impressive. We're very happy and very proud that we have such capacities within the Middle Eastern region, and to have such a lab with such advanced technologies and trained team in order to make sure that the equipment that we use for our solar projects are actually appropriate, adhere to standards, and are suitable for our local environment. Thank you for that, Munseb. Appreciate your time in here, and we have some questions for you for the Q&A section. Again, now I'll move to to the next, let's say, technology that we can implement in solar plants, which is robotics. We hear a lot about robotics, the role of robotics in solar parks, and the most important one is module cleaning, since we are in a region with high soiling rates, and that's something that is that impacts the performance of the PV systems. For that, we have today Dr. Raed Bkayrat from Alternative Energy Projects, شركة مشاريع الطاقة البديلة. I wish to welcome you with us. مرحبا أهلا وسهلا فيك. And I'd like to start with a question. We always hear the debate of dry cleaning, wet cleaning. What is your take on that? And do you think that dry cleaning is enough? And does dry cleaning help to maintain this low level of soiling rates in solar parks?
تحياتي منيف، السلام عليكم.
مرحبا والسلام.
مرحبا للجميع. طبعا هذا السؤال المهم، طبعا حتى كان في نقطة نعمل استبيان مع الحضور، لأنه دائما في نقاش إنه هل الدراي كلينينج تنظيف الجاف يكفي أو لازم يكون في ميكس بين الويت والدراي. طبعا بدي احاول انا بالعرض خلال يعني الدقائق القادمه اني اعطي توضيح لموضوع الدراي كلينينج، وانا طبعا رايي الشخصي الدراي كلينينج يكفي، وهناك محطات بالجيجا وات سكيل موجوده في الخليج، في الامارات وفي السعوديه، يتم تنظيفها فقط دراي، تنظيف جاف. فما بعرف حنعمل استبيان هلا، ما حكيت مع ملاك هلا ولا اخر العرض؟
بالاخر خلينا نمشي هيك نشوف الهي ونسويها باخر العرض لو
تمام
سمحت.
تمام. شايفين السلايدز؟
يس.
تمام. هلا زي ما تفضلت يعني التركيز راح يكون على موضوع استخدام الروبوتس في تنظيف الأنظمة الطاقة الشمسية وموضوع التنظيف الجاف تحديدا. في البداية بكلمة سريعة، شركة مشاريع الطاقة البديلة هي مركزها الكويت، مملوكة من كيبكو، شركة مشاريع الكويت القابضة. إبكو Alternative Energy Projects Company عبارة عن مطور مشاريع نقوم بتطوير المشروع والتنفيذ والتملك والتشغيل، فول أسيت مانجمنت، ومشاريع حاليا موجودة في الكويت، في السعودية، في الأردن، عمان. يمكن تختلف إبكو نوعا ما عن باقي الشركات اللي بتشتغل موضوع الاكويبمنت ليس. نحن نشتغل في مجال الكوميرشال اندستريال، الصناعي والتجاري، ولكن ايضا نشتغل في مجال البي بي ايز مع الحكومه، مشاريع كبيره مثلا مشروع عبري في عمان. ندخل موضوع الروبوتيك كلينينج. طبعا موضوع الكلينينج بشكل عام يعني بعتقد يعني مع انه صار تطور خلال اخر 4 أو 5 سنوات، لكن ما زال هناك نوع من نحكي المسكونسبشن او المس اندرستاندينج يعني بالنسبه لموضوع التنظيف. وطبعا السبب انه مشكله السويلنج، مشكله تراكم الغبار تختلف من منطقه الى اخرى. هناك العديد يعني مشكله غير معقده، لكن ايضا هي غير بسيطه يعني بشكل عام، لان هناك العديد من العوامل والمتغيرات اللي بتحدد طبيعه الغبار، وبتحدد الطريقه المثلى او الامثل للتعامل مع التنظيف. طبعا احنا بنحكي موضوع استخدام المياه للتنظيف امر غير وارد، فقط يعني احنا في مناطق يعني فقيره مائيا، وموضوع استخدام المياه للمحافظه على طاقه نظيفه يعتبر يعني في نوع من خلينا نحكي الجحف من غير ما نزيدها بالكلام يعني. ولكن طبعا ان شاء الله بالعرض هذا راح اثبت الكلام هذا. موضوع استخدام الروبوتس، طبعا الروبوتس بشكل عام تطور كبير، خاصه اخر 4 أو 5 سنوات مقارنه بال10 سنوات الماضيه. يعني اصبح هناك العديد من الشركات غير الشركات الصينيه تقوم بتقديم حلول روبوتات للتنظيف. اصبح هناك نوعا ما نوع من التشابه بين الروبوتات، اصبح يعني طريقه عمل الروبوت شبيهه من روبوت لروبوت اخر، الكونفيجريشن يختلف. والنقاط الاساسيه اللي بيتم التكلم عنها بدنا نتكلم عن استخدام الروبوت للتنظيف، طبعا موضوع اللي هو الابريجن، الخدش للالواح، الانتي ريفلكتيف كوتنج الموجوده على الالواح. 99% او 95% زياده، يعني الالواح جميعها عليها انتي ريفلكتيف كوتنج اللي بتساعد تقلل انعكاس الضوء الشمسي الساقط على البانل. لكن هناك نقاط اخرى، مش بس موضوع الابريجن للكوتنج لازم ننتبه عليه، هناك موضوع الميكانيكال لودنج على البي بي بانل اللي هو الوزن الزائد، الدايناميك لودنج اللي بيصير لما يتحرك الروبوت على البانل اذا كان ماشي على الفريمز. هناك موضوع طبعا الاستراكشر، يعني ما بتتكلم عن الاستراكشر خاصه اذا كان فيكستد او تراكر. فثلاث نقاط هي اساسيه، هي الكوتنج على البانل، اللودنج على البانل، وموضوع اللودنج على الاستراكشر. وطبعا كشركات زي ما انتم عارفين في عديد من الشركات تقدم حلول في مجال الروبوتيك كلينينج. هلا احنا ليش بنحكي موضوع تراكم الغبار؟ يعني موضوع فيه العديد من المتغيرات. طبعا الكاركترستكس للموقع، طبيعه الغبره الموجوده، حجم البارتيكلز، الفيزيكال ستراكشر للدست مهم، موضوع الحراره والرطوبه مهم جدا، موضوع التلت انجل الالواح مهم. كل ما زاد التلت انجل بتساعد على الجاذبيه، تعمل تساقط للبارتيكلز اللي حجمها مثل اكبر من 200 مايكرون. وبتساعد في المناطق اللي فيها رطوبه عاليه، بتساعد البانل تنظف نفسها من نفسها. حكينا موضوع الدست بروبرتيز والجليزنج والامور هذه كلها طبعا تدخل في تعريف طبيعه الدست اللي موجود في هذه المنطقه، وهي تعتبر الخطوه الاولى قبل ما نحدد نوع الامثل للتنظيف. فانا بدي اعطي مثال لمحطه مشهوره يعني هذا أول مشروع لمنطقة الشيخ محمد بن راشد في دبي. المحطة الأولى كانت للمزرعة اللي حاليا تحاول توصل 3 جيجا وات، هي 13 ميجا اللي تم العمل فيها بالعام 2013. المحطة من افتتاحها 2013 ليومك تنظيفها بالكامل دراي كلينينج، ما تم استخدام أي مياه للتنظيف ما عدا يوم التشغيل الكوميشنينج لما عملنا البي ار تيست. الطريقة المستعملة في هذه المحطة لقياس درجة الغبار لموضوع السويلينج ستيشنز، اللي هي المحطات اللي تقوم بدرجة الغبار على هذه المحطة. وطبيعة عمل السويلينج ستيشنز بيكون عادة في أكثر من محطة. في سويلينج ستيشن تنحط مع الويذر ستيشن اللي هي شايفينها باللون الأزرق اللي بتكون يعني بجانب الأو&ام بيلدينج. عادة هناك سويلينج ستيشن يتم وضعها أو زرعها داخل الطاولات نفسهم، وكل سويلينج ستيشن يكون لها هدف. هلا السويلينج ستيشن عشان بس نعرف كيف تشتغل، السويلينج ستيشن عباره عن لوحين بيكونوا ماتش، يعني فيري سيميلر، متشابهين جدا بالكاركترستكس، الاوبن سيركت تيست، شورت سيركت تيست والامور هذه. الستيشن اللي شايفينها بالصوره عليها لوح ثالث بيعمل باور سبلاي للاكويبمنت، بيشحن البطاريه اللي بتقوم اعطاء الباور للسيستم داتا كولكشن. وحسب الريسيرش طبعا البحث العلمي الموجود، احسن طريقه لدراسه او لمعرفه درجه الغبار على البانل هو قياس الشورت سيركت كارنت. هناك عده موديلز يعني، لكن الاسهل معظم الاندستري ماشي عليه هو قياس الشورت سيركت كارنت. فاللوحين موجودين في شورت سيركت وبنعمل كولكشن للديتا، والريشيو بيناتهم او 1 ماينس الريشيو بيناتهم تعطيك نسبه السويلينج اللي موجوده على اللوح. وبنفس الوقت طبعا هلا السويلينج ستيشن الموجوده مع الويذر ستيشن يتم ابقاء على لوح واحد نظيف بشكل يومي، فبالتالي نسبه البرفورمانس او شورت سيركت كارنت بين هذا اللوح واللوح اللي لا يتم تنظيفه ابدا بطريقه مانيوال، تنظيفه بيكون بعوامل طبيعيه اذا صار مطر او رطوبه، الفرق بيناتهم بيعطيك فكره عن نسبه السويلينج او نسبه الفاقد للطاقه للمحطه بشكل كامل اذا لم يتم تنظيفها. وهذا فاكتور مهم جدا. يعني انا لو احنا بنحكي التنظيف مهم وله وزنه وله طبعا عائد مالي، لكن اذا ما نظفت انا ايش نسبه الفاقد؟ لازم اعرف البيس لاين تبعي عشان اعرف ان الكوست اوف كليننج حسب الميثود اللي راح اتبعه والعائد المالي اللي عليه. هلا السولينج ستيشنز الثانيه بنحط احنا داخل الطاوله نفسها، فهناك بنحافظ على لوح نظيف بشكل يومي او كل يومين، ولوح يتم تنظيفه لما يتم تنظيف الطاوله نفسها. فيعطيك فكره برضه انه كيف الفائده من الفريكونسي اوف كليننج لهي المحطه. هلا احد النقاط اللي بسمعها دائما بالاندستري انه ايش السويلنج ريت للمنطقه هذه، وبدي احكيها هلا بصوره واضحه. ما في سويلنج ريت ثابت لموقع ثابت. السويلنج ريت لنفس الموقع معدل تراكم الغبار نفس الموقع بتغير. هاي الميجرمنت للنتائج اللي من السويلنج ستيشن اللي حكيت عنها قبل شوي. عندكم السويلنج ريت بتغير من 0.05% per day، هذا فترة الشتاء الغبرة قليلة، هذا بدبي طبعا، بتغير لحوالي 0.5% per day soiling، هذا في فترة الصيف. فممكن أحكي بمعدل تراكم الغبار في هذا الموقع على طول السنة، لكن ما في رقم ثابت. والشغلة الثانية الإمباكت تبع السويلنج لينير، ما في والله ساتوريشن بعد اسبوع راح تسكر البانل الاوتبوت بنزل للصفر، ما في منه الكلام هذا، الا اذا طبعا استركته لمده 6 شهور وصار طيني على الوجه البانل وصار في توتال بلوكينج لللايت. لكن عاده لما نحكي بسويلنج عادي الموضوع زي ما انتم شايفين لينير اكثر منه عليه ساتوريشن. ففاريبل سويلنج ريت لنفس الموقع، و اتس ا لينير ايفكت كريدكشن ان انرجي جنريشن. هلا في هاي نقطة مهمة، يعني أن المحطة اللي فرجتها 13 ميجا لو تركناها بدون أي تنظيف خلال السنة، طبعا كل أحد يحكي والله تركت المحطة بدون تنظيف في الصحراء في الإمارات في دبي راح تنزل 50% الأوتبوت كمعدل سنوي لحد ما يصير مطر في الشتاء أو يعني تيجي الفرص المطرية القليلة. يعني الواقع الرقم أقل من 6%. يمكن الرقم يكون شوكينج لبعض الناس، لكن لو تركت 13 ميجا في دبي في المنطقة هذه تحديدا معدل الفاقد السنوي لا يتجاوز 6%. معدل التنظيف احنا كنا نعمل مانيوال كليننج لهي المحطه حوالي اقل من 2%، 1.6. هلا ليش نحكي ب 6% معدل طبيعي للسويلنج لوس؟ لانه بصير عده، طبعا غير الايفنتس المطريه اللي بتصير، يعني بتمطر بالسنه مرتين 3 4 5، لكن بصير غيرها اكثر من 20 ايفنت. بصير تراكم للرطوبه، للندى على البانل خلال الليل. طبعا في فترات شهر 7 8 9 10 رطوبه عاليه جدا، الديو بوينت واطي، بصير تراكم للمياه على وجه البانل بالليل، تبرد بسرعه. وهذا هاي التراكم للمياه بيصير مع ميلة اللوح، بتنظف اللوح تلقائيا. فهذا مثال على مشروع ميجا وات سكيل بدون اي تنظيف، اللوس 6%. طبعا هذا بترجع للمالك المشروع، الاوبريتور، هل 6% مناسبه؟ هل انا اذا كانت تعرفه عاليه بيهمني انظفها؟ شو الكوست اوف كليننج والامور هذه كلها. لكن الموضوع مش تراجيك اللي بسمع والله لازم ننظف، ما نظفنا حيصير 50% لوس. طبعا الرقم هذا بيختلف، ما بحكي انه والله اي محطه لو تركتها حيصير اللوس 6%، لكن في الموقع هذا تحديدا بسبب الرطوبه، بسبب الندى المتراكم بالليل خلال فترة الأشهر اللي فيها رطوبة عالية، بصير تنظيف تلقائي للمحطة. وكل ما موقع آخر يختلف، عشان كل الواحد لازم يعرف بالضبط الظروف الجوية، نوع الغبار، والعوامل الطبيعية اللي بتساهم في عملية التنظيف، مهمة عشان نختار الحل الأمثل للتنظيف. طبعا المحطة هاي زي ما حكيت تنظيفها يعني أسبوعيا كان أعتقد، مرة كل أسبوع الألواح تنظف كاملة، كل يوم كان تنظف جزء، خلال أسبوعين يمروا على المحطة كاملة. حاولنا نشوف لو نظفنا يوميا مانيوال كان السويلنج لوس افريج بينزل تحت ال1%. فالديلي كليننج، التنظيف اليومي، هذا شيء يعني اعتقد يعني في معظم المواقع ممكن نوصل اليه، اذا صار تنظيف يومي واحد ممكن يوصل ل 1% سويلنج لوس. حاولنا بنفس الوقت نجرب روبوتيك كليننج، لو يعني استعملنا الروبوت للتنظيف عملناهم يوميا، كان نسبه اللوسز اقل من التنظيف اليومي اليدوي، يعني نسبة اللوسز هون وصلت حوالي 0.85%. فأكيد موضوع الأتمتة عملية التنظيف، موضوع الروبوتيك كليننج راح يعطي نتيجة أفضل وكلف أقل طبعا، وهذا كله بس دراي يعني من غير استخدام أي مياه. فممكن أوصل أنا لمعدل فاقد بالنسبة لتراكم الغبار أقل من 1% فقط بتنظيف جاف، سواء كان مانيوال أو روبوتيك كمعدل سنوي. طبعا هلا بنتكلم عن موضوع الميجرمنت. طبعا احنا عشان يعني نفهم احنا نسبه الفاقد او كلفه التنظيف والعائد المالي، لازم نعرف يكون عندنا في سويلنج لوس ميجرمنت، لازم نعرف احنا نحاول نطفئ ايش هو، شو المعدل، شو الامباكت اللي عامله على المحطه. وهذا يعتبر استثمار مالي بالنسبه للاوبريتور او لمالك المحطه. طبعا في عده ميثودز او طرق لقياس معدل تراكم الغبار. حكيت عن السويلنج ستيشنز، ممكن استخدام السترينجز، نختار مثلا في عندنا ماتشنج سترينجز، نختار يكون في hundreds thousands of strings بالمحطه، نختار سترينج 2 3. السترينجات دائما تنظيفها يومي او اسبوعي، وبقارن انتاجها مع الباقي السترينجات في المحطه، وهي تعطيني فكره عن اللوسز في هذه المحطه. هناك طبعا طرق اخرى منها اللايت ترانسميشن سنسورز، داست اي كيو منتج ممكن استخدامه. في برودكتس اخرى، في 2 او 3 برودكتس، لكن كتوبيك اعتقد لايت ترانسميشن سنسور ستيل ان ديفلوبمنت، وموضوع بتعمل كورليشن ما بين قيمه الفاقد اللي بتقراها من مثل داست اي كيو ومقارنتها بالاكشوال انرجي لوس، لسه فيها موضوع بحث اعتقد، ويعني هناك دراسات على الموضوع هذا. لكن النقطة الأهم اللي أعتقد يعني لازم تركيز عليها، أنا مش بحاجة لأي من أي هاردوير سوليوشن لقياس السويلنج لوس. ممكن ثرو داتا اناليتكس وديتا مايننج زي ما بيحكوها، إني أوصل لسناب شوتس، أخذ صور من برفورمانس المحطة، أعرف إمتى راح أعمل تنظيف للمحطة، وأقيس البرفورمانس بعد التنظيف مباشرة، أعمل كورليشن مع التمبرتشر، الراديانس، سرعة الهواء وغيرها، اذا كان في ديجراديشن بالبرفورمانس على البانلز، ريدكشن بالاوتبوت دي ريتنج على الانفرترز. ثرو داتا اناليتكس المفروض اوصل لامكانيه عزل الامباكت تبع السويلنج لوس، وثرو داتا بيورلي اعرف قديش نسبه السويلنج لوس لهي المحطه. كأمثلة نتكلم طبعا عن طبعا الروبوتس في عندها عدة كونفيجريشن. في روبوتس بتمشي على ريلز، الصورة اللي على الشمال احنا بنتكلم على طبعا روف. موضوع السيفتي مهم جدا بالحالة هاي، يعني في روبوتس تمشي على ريلز ما بتعمل أي لودينج على البانلز. إذا كان فيكس تيلت برضه ممكن تكون تمشي على فريمز للبانل، ممكن تمشي حتى على الاستراكشر نفسه إذا كان الاستراكشر بيسمح بانتجريشن لروبوتس. طبعا الروبوتس ممكن تكون فولي اوتوميتد، وممكن تكون روبوتس فور ايفنت كليننج. الصوره اللي تحت على اليمين هاي صوره من سان باور اللي هي او ان ام هلا نوفا سورس. عندهم روبوت عباره عن بيج ماشين طبعا وزنه فوق ال 100 كيلو، لكن هذا يعتبر ايفنت كليننج. يعني ممكن تحطه انت على محطه تكون يعني طينه على وجه البانل وينظفها. طبعا بيستعمل ويت كليننج، هذا بسميه روبوتيك فور سيمي اوتوميتد بنسميه، مش فولي اوتوميتد، وبيستعمل ووتر فور كليننج. وممكن الكونفيجريشن تبع الروبوتس يعني ياخذ اشكال مختلفه تماما. يعني هاي الكونفيجريشن او كونسبت بنسميه لاوتوميتد سولوشن. بكون هاي اوتونوموس فيكل، ممكن تمشي على الجي بي اس وتاخذ اي ترين على الارض، شكل الارض كيف بتغير. ممكن تتحول بلينير موتورز تغير الانجل تبعت البرش نفسها، ممكن تغير الهايت الزاويه. تكون فولي اوتوميتد تشتغل على اي محطه. وممكن اضافه حتى فانكشناليتيز عليها ثاني، ممكن نحط ثيرمال كاميرا. انت بتعمل يعني احنا بنعمل ديلي كليننج لمحطه الكامل، فبالتالي ممكن اصور اعمل ثيرمال كاميرا، ثيرمال ايميجينج، اعرف الهيلث تبعت الموديول، اشوف مايكرو كراكينج يعني في بداياته. فممكن كدياجنوستكس اخذ الروبوتيك كليننج وامشي فيه يعني لامور اخرى غير بس موضوع التنظيف. هلا بدي احكي شوي على موضوع الابريجن. هلا
لا لو سمحت ضل معنا شي دقيقة ونص هيك، ما كتير ضل وقت.
سريعا جدا. هلا اي لو تركنا البانل از از باي ظروف جويه بمنطقتنا راح يصير ابريجن على الانتي ريفلكتيف كوتنج. لما يصير دراي كليننج، حتى ويت كليننج بيعمل ابريجن. لو الدراي كليننج بيكون اسرع في موضوع الابريجن، وممكن نعمل ماثماتيكال موديلنج لدراسه اللوسز اللي موجوده على البانل. في بيبر مهمه جدا اشتغلوا عليها كيري وفرامنهوفر، ممكن تعمل انت ديريفيشن لموضوع ايش الاوبتيمال نمبر اوف كليننج سايكلز للسايت اللي ممكن اعمله. طبعا بيعتمد على السويلنج لوس كفاينانشال لوسز ككليننج كوست والتارف والامور هذه كلها. موضوع الستاندرد سريعا، ما في ستاندرد واحد للروبوت المستخدم في كليننج البي بي بانلز، لكن في ستاندردز بدنا نشوفها على موضوع الكوتنج للبانلز. IEC 62788-7-3 هذا جزء من الاي سي ستاندرد عن موضوع اللايت ترانسميشن للكوتنجز والانكابسولنس للبي بي بانلز. واي بريسل اي برش بتعمل ابريجن. احنا هلا الاندستري اغلب المصنعين راح يمشوا على النايلون، لكن زي ما انتم شايفين النايلون ممكن يعمل ابريجن اكثر حسب عدد السايكلز. طبعا احنا نفهم ب 20000 سايكل، يعني 20000 سايكل بتمثل اكثر من يعني 20 سنه ككليننج، لكن الابريجن موجود. في انريل عندهم وركينج جروب على موضوع السويلنج والكوتنجز. اتس فري، يمكن يعني هذا الايميل موجود لاي حدا بده يشارك فيها. هلا بملخص يعني النقاط لازم دراستها في موضوع اختيار روبوتس. طبعا الكابكس الاوبكس الار او اي، لازم يكون في فاينانشال موديل للكليننج. الكليننج لازم يكون يعني اعتبارها في ديزاين المحطه قبل التشغيل. موضوع البرفورمانس برودكتيفيتي ليفلز، السبورت تبع الافتر سيلز مهم جدا. في كثير شركات تشتري روبوتس من شركات يعني خارج الوطن العربي وما في اي نوع سبورت. موضوع الورنتي، السبير بارتس، ايش نوع التكنيشن ممكن يعمل لي صيانه للمحطه. وموضوع السيفتي مهم جدا خاصه في الروف توب ابلكيشن. كتيك اويز دراي كليننج از بوسيبل 100% ممكن اعمل دراي كليننج، لكن لازم يكون فريكوينت، لازم يومي ماكسيم خلال 3 ايام. غير هيك راح يصير تراكم، يعني في اكسبوننشال accumulation curve للدست. لازم يكون في wet cleaning اذا ما قدرنا نعمل خلال يوم او 3 ايام dry cleaning. الفريكونسي لازم تنعمل على فاينانشال تكنيكال موديل، مش يعني هاب هازارد. احنا موست اوف المودلز بشوفها بقول لك حسب المنطقه هاي بحط كوستنج ل5 مرات بالسنه تنظيف وبمشي عليها. الستاندردز موضوع بدا يتطور في مجال الروبوتس. الروبوت لازم يستعمل اوف ذا شيلف كومبوننتس مش بروبرايتري كومبوننتس، يعني ما في شيء سبيشال باي روبوت موجود. موضوع السكادا از اكزاجريتد برايي الشخصي بالنسبه للروبوتس. يعني بالاخر يعني مع احترامي الشديد لكل مصنعين الروبوتس، هي عباره عن يعني موفينج برش، يعني ما فيها الماجيك ان ذات سنس. وبالاخر السكادا تبعت البلانت لازم تعرف الروبوت اشتغل او ما اشتغل، نظف او ما نظف. ولازم يكون في كوستنج موديل. حتى لو تستعمل روبوتيك كليننج، لما تعمل كوماند فور روبوتيك كليننج هذا له كوست غير الايفنت كليننج. ولازم نعمل فاينانشال موديل وتكنيكال موديل على تحديد امكانيه التنظيف والكلف والعائد المالي. وهذه هي من طرفي. شكرا جزيلا.
شكرا لك. وهذا فعلا سأل هذا يعني قديش نحن بدنا تو انتجريت هذا الشيء بالايكونوميكال موديل للمشروع، عشان طبعا حيأثر على الإنتاجية وحيأثر على العائدات تبع المشروع لاحقا، وفي استثمار رأس مالي كبير في البداية. فكمان هاي الأشياء إن شاء الله نحكي فيها في الكيو ان اي. شكرا كثير لك دكتور رائد. الأسئلة شو رح نأجلها بس نوصل للكيو ان اي، لأنه ما ضل معنا كتير وقت، متأخرين نحن 6 دقائق. بنسويهم إن شاء الله في الكيو ان اي مرة واحدة، وبنتناقش بالنتائج التصويت. تمام. I'd like then to thank Dr. Raed Bkayrat again for his presentation. We are moving with a 5 minutes late throughout the program, but it's okay. We have enough time for the Q&A. And now I'll pause the recording for the upcoming session. And I wish to welcome Mr. Krunal Patel from ACWA Power, who will be helping us to understand the grid forming inverter technology and to see, as it is becoming a future requirement and an important aspect in microgrids. So welcome on board, Krunal. You have 20 minutes. Would like to get an introduction about yourself and ACWA, and also learn from you about the grid forming inverters, please.
Thanks, Moin. Am I audible?
Yes,
No?
Yes. All good.
And my screen is visible, right?
Yes.
Okay. So first of all, I would like to thank Solarabic for arranging such a nice and very informative online conference. And today I would like to put my thoughts on grid forming inverters, which is a future requirement and importance, especially in the microgrid project. Myself, Krunal Patel, and I'm working as an executive manager in Central Technical Service Renewable Department in here ACWA Power Dubai office. Briefly, I will try to cover the agenda in this presentation about ACWA Power's introduction. Then I would like to cover microgrid brief introduction. Then there are some of the main functionalities related to the grid connected inverters and its operational modes. Moving further, I will also try to cover the specially grid forming, why it is a vital technology for the weak power system. And there are some of the fault right through challenges which we are observing in grid forming inverters currently. And yes, what would be the future scope of this such a very good technology of grid forming inverters, and how currently where we are and where we were to go in this area. So first of all, I would like to introduce my company ACWA Power, which is a developer, investor, and operator for the power generation and desalination water plants with around 77 assets in the operation currently in around across the 12 countries. And with respect to the proven track record, from the 2020 to 2022, there are a couple of very renowned and innovation breakthrough projects accomplishment by ACWA Power, which is named, few of the names are Sudar PV IPP, which is the largest PV currently in Saudi, NEOM Green Hydrogen project, yes, one of the biggest microgrid in the world, which is a Raed project. Yeah, so from here I wanted to start covering my technical topics, and for that, the first slide where it is, I wanted to introduce the microgrid. So as we all know that the microgrid is a set of interconnected loads and distributed energy sources with well-defined electrical boundaries from which a single controllable entity acting as a grid can be connected or disconnected. So with respect to this diagram, you can able to see there are multiple IBRs are connected. So IBRs are mainly called as inverter-based resources, which is connected to the common bus bar, and from that common bus bar, all the resources are generating and transmitting active and reactive power to the load as well as to the main grid. So now it's very important to connect and disconnect so that to connect to the grid and working as an islanding mode. This is very important characteristic which is to be played by the microgrid. So apart from that, in the microgrid characteristic, if we see in detail, there is a PV and ESS required to be connected on the same bus bar. There is only one connection point between microgrid as an overall grid and the transmission grid. There is a complex control and relay protection system required. There is black start, which is the most important part in case of any microgrid requirement. Reserve power capacity is also needed, because in case of any black start issues, there will be the reserve power capacity which will help to start the microgrid. Grid fault withstand capability, and the one of the most important is a seamless transition between on grid and off grid kind of scenario. So this kind of microgrid characteristics is very important to adapt by the inverters. So inverter technology should be adaptable with respect to this kind of a requirement of the microgrid. The source of generation is one part, and the conversion is another very important part in case of any successful delivering of active and reactive power with respect to the stability of the grid, where maintaining the voltage and frequency within a specific band of that particular grid requirement. So moving further, in my next slide, I wanted to cover the grid connected inverters. So there are some main functionalities. So if you can see, grid connected inverters can operate either grid following mode or in the grid forming mode. This type of inverter should manage the DC link voltage. So if we see the PV inverter or the battery inverter, the input is on the DC side. So that DC link voltage should be the maintained. And for that, there is a requirement of the enough power electronics to adjust this kind of the voltage ranges. Inject active and reactive power to the grid. So this is the another part of the inverter, which is the AC side of the part of the inverter. So by maintaining the DC voltage variation and at the same time how to convert the active and reactive power with respect to the requirement of the grid, which is controlled by the either by the PPC controller or microgrid controller. The support grid for the voltage, frequency, and power quality. So as we all know that in case of the grid forming inverter, which is a specific requirement to maintain the voltage and frequency within the specific limit, stability against the grid fault. So now this is also very important for with respect to the various grid codes as well as the microgrid owned grid codes. So stability with respect to faults like there are LVRT, there are with respect to the low voltage right through faults, high voltage right through faults. This should be the characteristic to be defined, to be adjusted in case of grid connected inverters. So if you can see in the block diagram, there are the DC voltage control philosophies, then AC power control philosophies, which is divided into the grid feeding, grid forming, and grid supporting mode. Further to move, in case of the power theory, there are stationary frame alpha and beta, which is required to maintain the power angle of the output power angle, which is connected to directly to a grid. Natural frame ABC and the rotating frame direct quadrature frame control. So these three power theory to be utilized to maintain the stability in the voltage and frequency and to maintain a good enough power quality to connection for the grid. Further, to go in depth of grid connected inverters, there are various operational modes. So before going to the operational mode, there are some of the requirements like grid connected inverters should have a frequency control, should have a voltage control, system protection requirement, and the fault right through and voltage recovery. Now, if we see the basic architecture of any grid connected mode, which is a closed loop control system of the inverter, if there is a primary energy source is available, which is connected to first to the DC link. Now, this DC link is very important to get the closed loop feedback from the output of the inverter. So AC side of the inverter, which is given by the measured voltage and current, and which is given feedback to the DC side of the link. Then further, it is a switching, which with respect to IGBT kind of a switching, then filter circuit, and then it's output filter with respect to the capacitor type filter, and which is connected to the grid as a pure AC signal. So this is a closed loop control system where the sensing of the grid voltage and current plays a very important role to maintain the output of the grid connected inverter constant. Now, if we go in further depth of the block diagram, I would like to highlight over here, if the PV inverter is connected to the, in case of the microgrid scenario, it is connected as a grid feeding inverter, where it is where it is transmitting the active power and reactive power to the grid. In case of the sorry, in case of the any battery system is connected to the microgrid, which is connected as a grid forming inverter, where its main role is to maintain voltage and frequency of the microgrid. Now, with respect to these two separate characteristics, PV inverter is act as a current source, whereas the this battery, that is a PCS, we call it a PCS controller, which is considered as a voltage source of the inverter. Now, at the output of the voltage source, there is impedance, which is most important, playing a very important role for the identification of the right impedance matching with the grid requirement. And for that, this Z plays a virtual. Currently, there are many technologies are available to match this impedance technology with respect to the grid requirement. And virtual impedance matching technology is the latest one, where this impedance will be adaptable by the controller and adjust automatically with respect to the connection of the proper grid voltage and frequency. Now, apart from that, there is a measurement units which continuously sensing the output of the AC side of the connection and giving feedback, providing the closed loop feedback to the microcontroller, internal microcontroller of the any grid connected inverter. And based on that, overall the microgrid scenarios is working. Now, in case of the grid forming inverters, but it's a vital technology for the big power system. So first of all, I would like to explain what is a big power system. So generally, we have observed in many power systems, because of the currently lots of renewable penetration, the power system becoming a weak and weak day by day, and it's because of that there is a fluctuation in the power generation. The PV source is not a constant power source, where continuously fluctuation. And if we can see the duct curve, there is a huge depth of a duct curve we have observed nowadays. So in this type of scenario, the grid forming inverter can play a very important role to maintain three major parameters. First is the frequency, second is the voltage, and to maintain the SCR of the power system. Now, if we see any power system, these three parameters, the first, grid frequency. So in case of the any big power system, when there is a fault happens on the power system, the fluctuation of the frequency will happen, and the grid forming inverter should adjust that frequency to the certain band and limit that frequency. Second, the short circuit ratio. So because of the power electronics versus synchronous generator, short circuit ratio is very, very much different. So by adding the grid forming technology, we are actually trying to maintain the short circuit ratio equivalent to the synchronous generator. And you can see in this graph, it is very clearly visible that as the initial short circuit ratio is a constant, but as the short circuit ratio is reducing, the voltage fluctuation is becoming more and more. So to avoid this kind of scenario, the grid forming inverter plays a very important role. And third is the grid voltage variation. So with respect to the system voltage versus the natural voltage, as the SCR is increasing, it becomes constant. But as and when there is SCR lambda is reducing, the fluctuation becoming, the ratio is becoming less and less. So now, with respect to this, overall three parameters, the grid forming inverter can have this kind of algorithms and the static frame conditions, where to maintain the frequency, voltage, and SCR ratio of the grid. Further to next slide, I would like to explain about the fault ride through challenges. So now, in case of any microgrid scenarios, there are generally faults happens, and these low voltage and high voltage faults can create completely unbalance in the overall microgrid scenarios. So how this affects to the grid inverter? So once the fault reception, there is a risk of IGBT overcurrent happens, and this may damage complete inverter, and the voltage source may inject a very high overloading current at that time, and this overcurrent may trigger the device protection and it becomes the outage. Second, in fault, which is a risk of the control saturation. During the fault, which is LVRT or HVRT, the current limitation could eliminate the inverter capability to regulate the voltage and frequency. And third is the fault recovery. So risk of loss of synchronization after the fault. So once the fault is observed, the fault is clear, there should not be the loss of synchronization, because there are multiple grid forming inverters are connected in the parallel to act as a overall microgrid, as a to form a grid. In case of any of single inverter or will not be in the synchronization mode with all other inverters, there may be the chances of circulating current will flow, and because of this circulating current, there is a loss of synchronization may happen. So for that, there are multiple technologies or capabilities are generally developed by the grid forming inverter. One of them is it should have a droop control mechanism. It should have virtual synchronous machine characteristic, and it should act as a virtual oscillator control. So by this way, the grid forming inverter can accept the various fault right through challenges which can be generated in case of the microgrid. And lastly, I wanted to explain about the future scope of grid forming inverters. So this is one of my favorite slide, where we can observe from to start. Now currently we are at this stage of a grid forming inverters in a microgrid. Up to then later we have to further move in grid forming inverters in weak section of it becomes like a bulk grid scenario. Then it should be in a completely islanded mode. Then that islanded mode becomes the large isolated grids, and this grid forming inverter at the last fifth stage, there should be becomes a main or bulk grid kind of a scenario. If you can see, there are three stages of this kind of representation of a mechanical shaft, where these motors or synchronous generators are connected to the common shaft, which are weak links, and these loads are connected with the weak links. But in case of connection with respect to the smart PV and wind, when it is connected with the help of the grid forming inverters, it becomes a strong link connection with the mechanical shaft of this overall scenario. And further in the future, along with the PV plus battery, wind plus battery, this becomes the solid scenarios, and that there is no any weak link you can observe in the shaft, and this become a perfectly microgrid kind of scenario in the future. So currently we are in the present stage where there is early trends of grid forming application, identifying the research challenges with respect to the voltage control, frequency control, system protection, system recovery, and the simulation, modeling and simulation. And at the last stage, more than 6 years, if we reach after the 6 years, there should be the establishment of the technical standards for grid forming, standardized grid forming inverter models, and begin adoption of the grid forming inverters for the standard operating condition in the bulk grid. So this is what I feel the future scope of a grid forming inverter, where there is a big scope of new innovation. There is a big scope of wider range of the application to form a microgrid with respect to the considering the various renewable energy sources. So this is all from my side.
Thank you for that, Krunal. I appreciate the presentation and the efforts that you put into this presentation to teach us a new technology. Definitely also it triggered a couple of questions regarding the real difference between the grid following and grid forming inverters. Just let's say as not everyone is experienced with this technology. So that's very helpful. Thank you very much. We'll get back to this in the Q&A section. And for now, we'll just move to the last session before we go into Q&A. Thank you, Krunal.
Thank you.
Then I resume the recording now, and I would like to welcome Dr. Antonio Sanfilippo from the Qatar Environmental and Energy Research Institute, QEERI, and I believe probably you also have some other assignments as well, Dr. Antonio, and I'm very happy that someone would teach us and help us to understand the role of artificial intelligence in the energy sector, since it's not a very commonly discussed topic. We know AI on one side and we know energy on the other side, but that's bringing the two worlds together. That's something that is very exciting. Looking forward to it, and you have all the time that you asked for the coming 30 minutes for it. Thank you very much for joining us, Dr. Antonio.
Thank you very much. It's a great pleasure to be here with you all today. And many thanks to Solarabic for including me in this important and engaging events. So our topic today is was announced as artificial intelligence in energy management. And I want to start by saying a little bit about what we mean by energy management, especially in the context of this presentation. Essentially, it's the monitoring and control of global and local power systems that integrate renewable energy, energy storage, electric vehicles, and demand response. And the objective here is to optimize and secure energy use. So what are some of the problems? Well, it's great that we have more renewable energy because that makes power system more sustainable. But you know, there are also issues. So, for example, the increasing shares of residential renewable energy can create, as observed in California. You know, you're probably all familiar with the DAC curve. The first picture that you see there. And what that causes is basically when you have a lot of residential renewable energy during the day when everybody is at work, you know, you get a lot of PV generation, so a lot of excess power. But then in the evening, you have a sudden raise in demand. And that mismatch obviously creates stress on the grid and the energy market. And also, you know, electric vehicles can be problematic in this regard. Imagine, you know, in a small country like Qatar or the UAE, you know, millions of cars charging at the same time. You know, it can create an issue on the grid. So artificial intelligence can help address this complexity. So, for example, you can use forecasting to forecast your resources, and then a grid operator can schedule these resources in the most optimal way. Also, you know, Mr. Krunal talked about smart inverters in the previous presentation, and what's happening at the moment is smart inverters are you know, encompassing more and more of AI technology, and that makes it possible for smart inverters to address some of the complexity by you know, understanding what the problems are and providing a solution. So what we're going to do in the rest of the presentation is basically look at the use and the role of AI in energy management applications. As I was, you know, one thing that it's important here, that the application of these methods require a set of concerted activities across data processes, algorithm development, and computing infrastructure engineering. And I'm going to have a quick look at these three elements before we look into the application. So data, well, obviously, you collect data from the environment through sensors. And, you know, we've been talking about solar energy a lot. In this regard, solar monitor stations are very important. And I have an example here with reference to the network solar monitor stations that we have installed in Qatar. You want to have these stations all over the place because geolocation is very important to have precise measurements. And then you collect the various components of solar radiation, you know, direct, global, and diffuse irradiation in real time. Here I'm showing every 10 minutes, you can aggregate in all different ways. And these data are very important to develop some solar application, like, for example, solar forecasting. In addition, also, it's important to collect data about soiling. We saw in the previous presentation how soiling is a big problem in our region. Albedo for bifacial PV applications, and then other media parameters that are useful in improving results of models. Another example of collecting measurement through devices is phasor measurement units. And these are a class of devices that are becoming more and more popular to collect data from the electrical signal data in real time. We're talking about 60 to 90 measurements per sequence that typically are installed in the current and voltage transformers in the substation, distribution and transmission substation, and use GPS for time synchronization. A lot of applications that can be developed using this data, post-disturbance analysis, stability monitoring, and so on and so forth. We are currently completing an installation of a network of PMUs and a distribution network in education, city, community, housing compounds. So we're very, I think this is one of the first installation in the region. We're very eager to start working with the data we collect here. Another way to generate data is in the context of digital twin and simulation. And someone has already talked about the importance of digital twin in the previous presentation. Here we're looking at some work we did a couple of years ago on how to instrument a scenario where we generate PMU data. And basically, this consists in creating a virtual model, a software model of the phasor measurement unit, and then having a virtual representation of the power network where you want to apply the PMUs, and then use the Opal RT real-time simulation to actually, run as you were a power grid with those devices in and generate the data. And you can use the data for, to develop your applications and testing. Okay, so the last element here about data concern what is usually called data wrangling. And the idea here is that you collect data, you need to make sure that the data you collect are correct. You're all familiar with the datum garbage in, garbage out. So you need to make sure your data is correct. I'm taking an example here for solar radiation measurement. There is a protocol, the BSRN, which is basically a battery of control tests that you apply to remove physically impossible readings. So, for example, GHI, global, direct, and a diffuse irradiation cannot be less than -4 watts per square meters. And we're doing work at QEERI to expand the set of battery tests. Okay, so I want to look at very quickly at algorithm just to, what we're talking about when we're talking about this model. So the two machine learning algorithms that are mostly used in applications are classification and regression. Basically, classification, you're predicting specific values, like, tomorrow is going to be hot or cold. Whereas with regression, you are predicting specific numeric values. So, it's going to be like 40 degrees at 2 p.m. A very important development is deep learning, something really taking over the field of machine learning. And the idea is using a neural network to recognize underlying relationship in data points in a data set. A little bit like people do it, or at least how we're supposed to do it with our brain, and hence the neural network paradigm. The two important things is that, first of all, features are automatically extracted from raw data. So, for example, if you look at the example here, the pixels that are associated with the recognition of the square, the triangle, and the and the circle, they are learned automatically by the machine. They're not. You don't have to specify beforehand. And the other good thing is that the model keeps improving as data size grows. So the more data the model sees, the better it gets. So that's also very good news. These are, some of the uses that this algorithm. I'll be talking more about this as we go on forecasting and optimization. So I won't say much at this point. The last thing about methods is that you develop your models. You need to understand how reliable they are, and in particularly what is the uncertainty of this model. For classification, usually this is done by measuring the balance between precision and recall. For regression, what you're doing, you're essentially measuring the error rate between observed and predicted values. And there are various measures of how to do this. Okay, so moving on, computing infrastructure. This is very important, because AI, after all, does build on digitalization, and the way computing infrastructure has really developed in the last 20 years or so is a layer starting with edge nodes, where you have your sensor, your IoT devices kind of wired using local area network, either wireless or wired, and that's how they communicate among each other, and up to the next level where you have some sort of server machine that can do the processing, and this can be in a it can be a small server in an institute or something, and this layer is usually called the fog layer, or up to the cloud, where you have really big machines to do really intensive computing and also data warehousing. So very important, because in all we do in energy management using AI, we're using this kind of infrastructure. And an example of this is some work that we're currently doing for a project on energy efficiency in indoor farming. So we have a variety of sensors installed in a greenhouse, hydroponic greenhouse, to monitor the soil parameter, power parameters, and also the plants by taking pictures of them. And all the sensors are enabled with radio frequency capability to communicate with a gateway, with all the information is gathered and then shipped to the cloud through the Wi-Fi protocol, shipped to the cloud, where you can do some really intensive computing. You can use machine learning algorithms. All right, so finally, looking at some specific application, I'll look at about 3 classes of application. Cannot review everything in the short time we have here, so I'll try to pick and choose in a way that is hopefully engaging for you. So one area is the prediction of energy supply and demand. This is very important to address the intermittency of renewable energy resources. So, you can determine where to store excess energy and how to balance supply and demand. And you can see in the right hand how this goes at the high level. You have your solar radiation data, your energy demand data, you create the forecasting model, and then you have a forecast of solar energy the energy available. It could be some other energy, wind. And you have the forecast for the demand, the consumption. And then with that information, you can actually do an effective and optimal scheduling of when to use and how to use battery, how to turn on gas-fired plants, ancillary service, and so on and so forth. Another important aspect of this is that you can provide energy prices in the market ahead of time is very important in facilitating the market. By the way, also very important in developing energy blockchain to be able to forecast generation and demand. Obviously facilitates peer-to-peer trade by creating essentially pair traders ahead of time. And the other element is energy efficiency through demand response. And here, demand disaggregation is one of the relevant application. I have a slide on this. I'll say a little more about what it is. So one thing about forecasting, one of the challenges is that when you do forecasting, you recognize that no single model can give you the best answer all the time. So even the worst the worst performing model, does give you a good answer in some kind of context. So how do you leverage that? Well, one possibility is to put classification and forecasting together. So, for example, we start with our solar time series data, and then we develop different models. In this case, say we develop 4 models. And then with the evaluation data of this forecasting model, we develop a classifier which tell us for each choice of input time series, what is the best model to use. And then at runtime, we essentially run the classifier for each input. It tells us, well, that for this input, that particular model is the best, and so on and so forth. So we're basically leveraging classification to choose the best forecasting model. And in the experiments that we carried out, there is a significant improvement when you do that. You can see, a 5% errors versus 12, 9, 51, and so on and so forth. Okay, so I was talking about demand disaggregations. What is demand disaggregation? The idea of demand disaggregation is to essentially disaggregate the overall consumption, the aggregated consumption that you can have in a house, into specific appliances. So, washing machine, dishwasher, fridge, and so on and so forth. And the reason to do that is that, you need information about the appliances in order to do demand response, which loads to hold, execute, or, schedule in an optimal way. And you can do this with smart plugs, but obviously smart plugs, it tends to be expensive and cumbersome. So the idea is that you have machine learning doing the job for you. And the way you do this is you always start with a training data set. I'm showing here the UK Dale data set, where basically you have information about all the different appliances used throughout the day. And then you use the model developed with this data to execute at runtime to understand how to part the overall consumption into appliances consumption. The next example I have concerns, we already seen this, the optimization of energy use in indoor farming. So as I was saying before, we're working with the greenhouses, installing all kinds of sensors that provides information about soil, power, and also, and then we feed this data into a plant health model, which gives us information about what size and quality of fruit we can expect, and then machine learning taking this data to optimize. And one thing that we do in the optimization, showing this slide here, to identify trade-offs between energy use and crop yield. Obviously, especially in the warmer and hotter months, the more energy you use, the more you can cool and the better environment for plants to grow. But there is a trade-off. At a certain point, you're not going to get the money that you putting into energy in terms of revenues from crops. And also at a certain point, it doesn't matter whether you cool more, you're not going to get any more produce. So it's very important to understand these trade-offs. Switching off to grid optimization and resilience, as I was saying before, real-time data is very important to develop algorithms that can detect anomalies, predict equipment failure, optimize energy flows, and particularly enable early fault detection and rapid response. And the kind of problems that we are dealing here are voltage irregularity, line faults, and things like that. So I want to give you a very quick example of how we do this. So we collect using phase of measurement unit data. We collect the data, we have this data collected from previous historical data, which consists basically of the measurements, voltage, current, for angle and magnitude for all phases, and whether they're associated with fault or not. So basically you use this data to develop a classifier, which then you can run in real time with streaming data to understand whether a particular set of measurements is indicative of a fault happening or not. And in the same way, you can do forecasting, except that your data input is going to be more complex because it's going to be series of measurements. Okay, I want to turn to the last class of application, which is maintenance of energy assets. And again, this has already been discussed in previous presentations today, the importance of reducing the possibility of asset failure and, both to reduce loss, increase revenue, so reduce loss, and but also get the most out of your equipment by making it last longer. And typically what you do is like you collect information about the past asset performance, then you develop baseline models using machine learning, and then you ran the models with streaming data, and you get some action to perform. I want to give you an example of this, and this, I think, is my last example. With respect to thermographic analysis of PV modules. So, one thing that when you have a PV plant, modules get damaged. It's very important to recognize this damage, these faults, as soon as possible for two reasons. First, to avoid further damage, and then to, obviously avoid additional power losses. So the way it's done, it's basically you start always with a data set, which is your training data set, where you have a collection of all the faults that you see in the past, right? And then you feed, so you have basically a picture and a description of the fault, and so on and so forth for all the faults. And you feed that to a machine learning algorithm. In this case, convolutional neural networks are very good at recognizing classes from pictures. And you have then your fault detection model, which tells you for each panel input what is the likely fault to have occurred. And then at runtime, you feed pictures of the panel, your PV plant. You can collect these pictures with a drone fitted with a thermographic camera, especially in the case of a big plant. You don't want to go there with the handheld device, take too long. And you feed it to the model, and you get a response as to whether the picture of the model is indicative of a fault or not. Okay, so these are my last couple of slides. I want to say something about market size, growing very strong, about $24 billion in 2021, expected to grow to $113 billion. Now the interesting thing is that a significant part of this is really, so AI energy management is for renewable energy. And another interesting thing is that it tends to grow. So it was 34% in 2021, is expected to grow to 67%. And it's not surprising because, you know, renewable energy is ramping up. The adoption of renewable energy is ramping up. So very interesting to see those figures. Okay, I have one more slide, which looking at the next step. And in particular, I'm looking here federated learning. And what federated learning is basically doing computing modeling at the edge, using resource-constrained computing devices like a microcontroller to do actually some training at the end instead of doing everything on the cloud, everything under the supervision of a central server. And the benefits here is that because you don't ship the data to the cloud, you do the data crunching locally. It's more security. It's more secure, lower cost, lower complexity. Not so much cloud cost. So it's I think it's something for which we do have the technology now, and I think we're going to see more and more of this in the future. So in conclusion, I think AI is central to the development of energy management application. I think everyone would agree with that. The use of the AI in energy management require collection, generation, and wrangling of energy data, development of suitable machine learning algorithms, and the creation of appropriate edge-to-cloud computing infrastructure. And looking at the next step, federated is certainly a good one. And with this, I'd like to thank you all. And
amazing. Thank you. Thank you very much, Dr. Antonio. That's a very interesting topic. It's fascinating to see how these two worlds are getting closer to each other. The data analytics, the big data, AI from one side, and energy from the other one. Definitely, you have presented multiple applications for the home applications, for some special applications like in agriculture and at the grid level. That's something that we'll get back to in the Q&A. I'll let you now take a little break, 5 minutes. We'll leave your questions to the end, and now we'll start with the other speakers. As we move now to the Q&A section, where I invite all the speakers today to open up your cameras, microphones, so we could discuss further and answer the audience's questions. The way that we will do it, we will do everyone's questions except Dr. Raed's till the end, so we can group them and answer them in Arabic language in the end. Yeah, so that would make us a little bit more efficient in managing the questions. And I will repeat this in Arabic and get back to English again. أعزائنا الحضور، سنقوم بالإجابة على الأسئلة الآن. سنجيب على كل الأسئلة باللغة الإنجليزية ما عدا الأسئلة الموجهة للدكتور رائد بكيرات، والتي سوف نؤجلها لبعد 15 دقيقة تقريبا للنهاية حتى نجيب عليها باللغة العربية للجميع. يعني الإجابات الأولى ستكون بالإنجليزية، وفي النهاية سنقوم بالإجابة على موضوع التنظيف باللغة العربية بالذات، لأنه في وردنا الكثير من الأسئلة منكم، إن شاء الله رح نحاول نجاوب عليها كلها. So we're getting then to the Q&A, and I'll share here pretty quick my screen, and then we'll put the questions on. First question that I received for you, Hugo, please, from Mr. Abi Khalid Saeed Ta'i, who says that you offer this whole, let's say, CNI solution for companies or so, totally financed, to supply electricity to that facility, a factory or a warehouse, doesn't matter. Now, do you have in your models the potential not to sell electricity, but provide cooling or heating, let's say, as an end product, and rather than electricity?
So Siraj Power as such, no, doesn't. But we have a sister company called Taka Solutions, which now has added this to their portfolio. So their offering is used to be energy efficiency, and now the cooling as a service has been added. But as for Siraj Power, we focus on power. So we have looked at opportunities to work jointly and to have one single interface, but basically the cooling part would be Taka Solutions scope.
Taka Solutions scope. Okay, perfect. And now the next question is that for your business model, do you provide this PV plant, let's say, with this clean energy in an OPEX model, or is there like an upfront payment, or there is still a CapEx element for your clients?
No, it's a fully OPEX model.
Fully OPEX model.
So there is like a marginal mobilization fee, so but basically it's a pure OPEX model, which still comes with a minimum commitment, obviously. So there is a minimum offtake that the off-taker commits to purchasing every month. But no, there is no capital expenditure involved.
Interesting. And where do you see the this? In what countries in the Middle East do you see that kind of model supported? Obviously, here you're converting to some kind of an IPP, right? In this case, do you sell electricity in the end, or you don't need an IPP laws in order to implement that model?
So I would say it's more a question of baseline costs. So basically, we currently target geographies where diesel costs makes it not very cost efficient to run on diesel. So basically, you will first target areas where actually your landed cost of diesel, that's the most important thing. So it's not the cost of diesel at the petrol station, but it's the cost of delivered diesel. So you might have some cases where the official diesel price, let's say, is only around 40 dollar cents, but actually the actual cost for the off-taker is almost double, due to maybe because they're operating in a remote area and it is very difficult to deliver diesel. So what we look at is the landed cost of diesel. And this is actually what will drive the demand, more than a regulatory question, because usually there is very little regulation for off-grid power generation.
Okay, so this is, let's say, mainly applicable in the off-grid application, so you don't have, which is not regulated in most of the countries.
Again, yes, I was referring to what I presented, so our off-grid customers.
Okay, and I have a question that is more related, let's say, to quality from Mr. Hali bin Said, who says, for such off-grid applications, how can the customer guarantee the quality? Let's say for certain equipment, there are some kind of IEC standards for modules, inverters, and so on for quality of each element, but other system, what would guarantee, or how could the potential customer guarantee the quality of such system as a whole?
So again, the service we deliver is basically power energy.
So you take the full risk as a developer.
Exactly. We take the full risk. Of course, we want to strive for the best quality. Otherwise, this could lead to a reduced asset lifetime. We would have to replace some modules, some energy storage. So ultimately what the customer really cares about is how much they will be paying for the electricity, and make sure that power is available at all time.
Perfect. And I think this leads to the what you talked about, like the about gathering all of this big data and analyzing it. Obviously, this helps you to calculate the risks, let's say, in the projects, and improve the design and equipment, let's say, as implementation as you move forward. And now then comes the next question from an anonymous person here, who says, do you use, let's say, some industry known software for that, or is that some kind of an in-house solution that you have developed within Siraj?
I mean, that will depend for which part exactly.
You spoke about machine learning, gathering big data and machine learning and all of these analysis. So is that done in-house?
So it is not in-house, but by assembling, of course, existing modules. Some of them could be open source. Some parts we will get support. We will outsource some bits. But yes, let's say it's a puzzle, which is our own puzzle, but we assembled existing pieces.
And what would you advise? Because obviously the people have listened to this and they're sort of asking about what kind of tools or softwares that they could use. Obviously, there's a high interest to learn how to do this. So what would you advise, let's say, an engineer with fresh engineer or somebody with 1, 2, 3 years of experience to learn in order to develop their skills in that in towards that direction, to be able to do such kind of analysis?
I think we need to be a bit more specific regarding which modules we're talking about.
If you prefer, let's say, to narrow it down, obviously there are certain, let's say, every equipment comes with its software, and still you have also these kind of monitoring solutions that are available in the renewables world to monitor and to collect data. But to do machine learning and to run analysis on big data and come up with, let's say, useful outcomes or recommendations or findings and so on, that is more or less like probably more or less like a manual effort, or right?
So, I don't know if this will answer your question, but if we should if there is one area that it is critical to put some effort is into understanding the different load patterns. So actually, it relates a bit to the last presentation we had, where we need basically to kind of disaggregate the load demand. Okay, so obviously one could install a bunch of energy meters and sub meters at each client, but first of all, this is very intrusive and probably not cost effective. So basically, the idea would be to be able to what the goal is to be able to recognize, to identify load patterns depending on the application, right? So trying to understand how to disaggregate the load of, for example, a rock crusher, like a large quarry. How to disaggregate the load of a camp in oil and gas, for example. How to disaggregate, and then in order later to be able, just by having a list of connected appliances and maybe just a few weeks of historical data, to be able to build the forecast for the next 5 or 10 years. So this is basically where the main effort should be concentrated, and this is where one can really bring value. So I mean, my recommendation for, as you say, like a fresh engineer would be to look at a lot of an extensive set of data gathered from different sites, different applications, and trying to cluster it and understand how to recognize patterns, and then how to disaggregate the load demand.
Thank you for that, Hugo. Probably last question that I have from Mr. Omer Ahmed for you is you presented the chart in slide 9, I think, about this charging profile of the battery together with the generation profile of the solar system, and he noted that why solar power is wasted after charging the batteries. I believe that because you cannot push it to the grid. Yeah. Please.
Yes.
It can be used to supply the load as well as should have been made by proper design calculation. So maybe Omer here argues like if the sizing is done well, then you should not end up with excess of energy. Yeah.
Yes,
what is your comment on that?
Yeah, which was actually my point. So basically, the risk without a good understanding of the load is, well, undersizing or oversizing. Actually, so oversizing is a more of an issue because you've overinvested and you're unable to pay back your equipment. So the example I showed is what happens if you oversize your system. And one of the main reasons you would oversize your system is having an accurate forecast of the load. Right, so this is why it is critical to be able to forecast the load, but not only the aggregate value over a year or month or even a day. We need to have an intraday understanding to make sure that we do not end up curtailing and wasting energy, too much of the energy.
Thank you for that. Yeah. I think this answers the question, if I understand it right. Thank you very much for that, Hugo. And I'd like to move to the next set of questions to Munseb, please. You presented these different ways of testing the inverters, whether like it is a solar inverter or inverter that is used for energy storage systems, which has gotten into a lot of technical, let's say, details. Obviously, most of the sellers of these products claim that they conform to certain international standards. Yeah, they conform to this IEC standard or the other one. Now, in your opinion, do you believe that we need more rigorous tests in excess of what is stated there in these IEC standards in general?
Yes, this is what I also mentioned during my presentation. For certain certifications, they do have their limitations. So if we dive into the scope of methodologies and the method of statements for testing of each inverter under the set of the certifications the manufacturers actually acquire from the third parties, they majorly focus on the safety of the inverter operation and the safe synchronization of the on-grid inverter with the grid. So they don't dive deeply into the reliability, evaluation, and performance of the inverters. You know, like on each project, we have to install inverters in different scenarios. Maybe somebody is installing inverters in an air-conditioned control room. Some might be installing under the sheds. Some might install it under the PV arrays. So we need a rigorous program. Like we need to run the inverters to rigorous different scenarios of environments in order to check the reliability and the performance of the electrical components within those inverters, and that needs to be inspected very thoroughly.
And based on that, let's say if a product passes your lab test, and then it gets, let's say, passes the tests and then gets certificate from your side. Obviously, it comes with a set of certificates from the manufacturer first of all, and then it gets installed. Now, do you recommend also some kind of tests on the field? Let's say after installation, probably at commissioning, or maybe during the operations and maintenance phase.
Yeah, actually, in our industry, there is a very sad dilemma. There is an issue. Most of the time, once you talk about the certification or the third-party testing of the laboratory, the inverter manufacturers do not allow you for it. For example, if there is an inverter manufacturer and he wants a product to be tested on the field or even in the laboratory, he believes that he should be the one to initiate it from himself. he would never ask the customers, he would never like the customers to initiate it. You might have seen right now in the industry, whenever it comes to the commissioning stage, the inverter manufacturers, they mobilize or they engage their own resources to ensure the smooth commissioning and the soft start of the hot start testing of the inverters. They never like the third party to be involved into it unless the customer actually seeks or demands for it. Yeah.
Okay, very important. And do you see a trend towards customers asking for a third party to perform that?
Yeah, I see. Because for GCC, particularly Saudi Arabia, the weather conditions are quite harsh. Like even now, we have been talking with SASO and IEC to develop a new set of desert codes for the testing of the photovoltaic modules, because we believe that the modules which are tested in other regions of the world, they do not cater to the harsh conditions that we have in Saudi Arabia. So similarly for the inverters, yes, this trend is now very booming, and people and the customers are asking for on-site testing of the modules as well as the inverters.
Okay, I want to ask you, please, Munseb, like from modules world, since I worked for a module manufacturer before, I understand that for PV modules, it's important to look to the BOM, to the bill of materials, to understand that if it is tested with a certain BOM and it complies, then the modules are supplied with different materials that comprise this module. Then you might end up with different quality metrics in the end, or a different performance in real conditions. Is that also applicable for inverters? Maybe you can shed some light on that.
Yeah, for inverters, it is almost like a similar scenario. For example, you have a project and you got the delivery for the inverters on that site. So maybe you get a delivery from different production dates or from different stockpiles from that manufacturer. So within the inverter, there are so many electronics. So the inverter manufacturers, they rely on the supply of the electronic chipsets and their electronic BJTs, IGBTs from different suppliers. So there might be a scenario that you got some of the inverters which have different electrical components from a different supplier with different characteristics, and there are some other inverters which are from the fresh lot of delivery from the inverter manufacturer, with having different manufacturers electronic components. So each electronic devices, they behave differently to different design assumptions or different installation scenarios on the site. So this is highlighted as a mismatch itself for any project, for the mismatch of the inverters on the site.
Thank you very much, Munseb, for the information. I think we answered all the questions that we have got regarding that part. Thank you for that, Krunal, Munseb. And then I'll move to Krunal, please, to answer a couple of questions that you have received, starting with the most generic one, maybe like to come back to the basics. So Mr. Muhammad Naseem asked, what is the difference between the grid following and the grid forming inverters, by definition?
Yes, so generally grid forming inverters are the inverters which are the voltage source inverter. We generally call it as a voltage source inverter, and this type of grid forming inverters maintain voltage and frequency of the grid in a stabilized condition, whereas grid feeding mode inverters are a current source inverter, and mainly this type of inverter are used for the feeding active and reactive power. So mainly they have a control of current at the grid level, and they are not engaging with any impedance matching load, whereas a grid forming inverters have to have a matching requirement with the grid impedance to maintain the voltage and frequency in a stabilized condition.
Yes. Thank you, Krunal, for distinguishing these two. Now, I have a question, like saying that is PV plus BESS, like in the end of the day, enough to do black start in this, let's say, microgrids, and to make sure that we have, let's say, more or less like a resilient microgrid?
Yes, so nowadays we have also observed there are a couple of OEMs. They have developed the PV plus BESS with the black start feature. So generally in the black start features requirement, you have to have around 30% of SOC remains inside the battery storage requirement, which is specifically used in the case of the black start requirement. So in case of there is no power available, then that 30% of SOC will be helpful to generate power to give the power to the all the controllers, and from where the battery start working as a dispatching the power to the grid in the microgrid. So like this way, PV plus BESS can be worked as a black start, but at the same time the inverter should have feature of the grid forming requirement.
Okay. And last question, please, for you from Mr. Omer Ahmad, who says to Mr. Krunal, how are different AC power supply generators, solar, wind, and diesel, are connected to the grid bus bar without synchronization? How to ensure the matching voltage, frequency, and phase angle?
This question is to me?
Yes.
Yeah.
Okay.
Please. Yeah, so in case of the microgrid scenario, that's what the importance of the grid forming kind of inverters, where all the generation unit, which is called as DERs, which is distributed energy resources, these all DERs are connected to the common bus bar, and the grid forming inverters require to maintain the voltage and frequency of the bus bar at the same level to avoid any kind of a circulating current to be flowed inside the generation units. So and this grid forming inverter should maintain the frequency and voltage such a way that at the same time the PV inverters or kind of a beam generator can be dispatched active and reactive power inside the grid microgrid kind of scenario. So that's why the importance of the grid forming inverters is very much specifically in case of where the multiple DERs connected on the common bus bar and form a microgrid.
Perfect. Thank you. Thank you for that, Krunal. I think we answered all the questions related to your section. I appreciate your time, Krunal. And then we move to Dr. Antonio, please. Dr. Antonio, I have the first question from Mr. Ammar Saad, who says who speaks about collection of data. Obviously, if you want to, you need data first before you apply any artificial intelligence. Your data set is important. Now, he asks if it is calculated or gathered in real time, automatically or manually. But I'd like to extend this question to say that in our region, let's say in the Middle East, in the GCC, yourself, I believe you are based in Qatar. How is it possible to collect big data? Yeah, like really to connect to every system, to build a database of millions and billions of records in order to generate proper intelligence. We have seen, let's say, individual companies trying to do that, like Mr. Hugo from Siraj Power said that they have all their projects connected to one database, they have this big data. But what if we want to go beyond one company's projects and get to the whole country or region? Then do you think that is possible practically, and that there are some steps or any organizations that are actually building such kind of databases?
Thank you for a very interesting question. I think there are various ways of addressing this question. The first of all, you need to activate the government and private companies. So, for example, utilities, talking about our areas, have huge amounts of information that they collected since they've been around. Now that utilities in our region are starting to implement, to install smart meters, that is a huge amount of information coming. So there is already a kind of legacy information that is there and needs to be activated, making the the appropriate connections with the government and private bodies they have this information, and utilities are at the front of it. The other way is you need to install sensors, because there are certain things that have not been collected. So we're talking about phasor measurement units. These are new devices that a lot of the utilities in this region have not installed yet. So you need to take the plunge, so to speak, as a in our case, as a research institution, and do the initial installation to start collecting the data, and then convince the let's call it the utility power that be. That is an important aspect of this. Another thing is that you can collect data, massive data, by area survey. That's very important. We're discussing for PV maintenance. So I would say generally, there are two main direction. One is you need to make the connection with the relevant organizations that have the legacy data, and then you need to activate new ways of collecting the data by installing new sensors.
Mm-hmm. Thank you for that. Obviously, new sensors also is more cost to the project in a very cost-sensitive, let's say, industry, and we've seen, let's say, a lot of resistance, even though, let's say, a lot of aspects like thermal imaging through aerial, let's say, drones and so on, has been common in many parts of the world, but in some other parts they are less common because it's an additional cost factor that is usually avoided in where LCOE is optimized, let's say, to the last cent to be competitive in these countries. Now, I want to ask you, do you think that AI is, I believe some still think that it is futuristic, something it's kind of luxurious, something that it is extra cost. So, like kind of all of that. If it's like in Arabic, there's a saying that the people will speak Arabic will understand me, ما بتعرفوا بتجهلوا, which means things that you don't know, you can misjudge them in the end of the day. So what is your take on how AI actually and advanced analytics of big data can improve the economics of projects if we look to the lifetime of the project, let's say, in total?
Yeah, the proverb you were mentioning, it probably applied 20 years ago, where AI was still kind of proving itself. But I think at this point, everything you touch, almost everything you touch, has some kind of AI algorithm in it. So the question is not, the question is how to use it in the most optimal way. And what we need to do, you need to perform a techno-economic analysis to understand what is the return on the investment. This is possible to do. This is what we do in all our projects. Adding sensors to the farm, of course, there's a cost. Software, there's a cost, but then you can prove that the benefit that you have actually gives you an advantage. So, but it's incumbent on you as the researcher or as the operator, the technology operator, or the company providing the service. It's incumbent on you to prove that there is an ROI, and it can be done. There are techniques to perform that techno-economic analysis.
Okay, thank you for that. I'll ask the last question, very similar to what I asked Hugo in the beginning of the session. Since we have a lot of fresh graduates and new engineers, let's say, on board here attending, and we always get the question, like, how can we actually develop skills to do this unconventional, let's say, jobs? Like kind of, they're always like solar designers, solar installers, and so on. But here we talk about AI and big data, how they could help to optimize the performance of these of the power systems, of the grid itself. So what would you recommend to fresh graduates like now in order to learn and to develop their skills to integrate AI into the energy sector?
Yeah, very good question. I think, definitely learn the tools of the trade, get the knowledge of machine learning, what are the techniques, how to use them, what are the most effective, especially in the area in which you work. And from the point of view, look at the tools. So, for example, if you're an engineer, I think nowadays in the current situation, you need to learn Python, because all these programs are developed in Python. And this may change in the future as it changed in the past. At the moment, learn machine learning and start getting into new areas to be ahead of the game. So federated learning, a very good area to get into. I think it's going to be the way to the future, because there are so many advantages of it. So, that is what I would suggest.
Thank you for that. Okay, with that, I think I conclude my questions to you, and then we'll be moving to the questions to Dr. Raed, which we'll do that section in Arabic, but I don't want to keep holding you in case you need to leave earlier. I wish to take the moment now to again thank Mr. Hugo Gaillard from Siraj Power, who presented to us a very unique and interesting business model that Siraj Power is implementing, and technologies that they are using to optimize the performance of their assets and to improve the economics for their customers. So thank you very much, Hugo, for all of your input and presentation.
Thank you very much for this opportunity.
Thank you. And then I wish to thank also Munseb Mohammed from GCC Lab. Gulf Renewables Lab is one of the leading labs in the region that is doing a great job to test and to certify solar, and not just solar, but renewable energy equipment in general. And he has given us a very good overview of how do they do that for inverters. Thank you very much for your participation. I wish then to also thank Mr. Krunal Patel from ACWA Power. Krunal has given us a very interesting and very comprehensive overview about grid forming inverters. And it is a technology that is, let's say, gaining popularity, has been spoken a lot about it. And I think we would need to have a dedicated session about that topic, because 20 minutes can never give truth to such very important technology. Would be very happy to host you also in the future with more time in order to talk more about it. So thanks for that. And then in the end, Dr. Antonio Sanfilippo, you have given us, you opened our eyes into how close is AI from being practically, let's say, used and implemented in the energy sector, and how it has already been used, and how hopefully this has triggered a few thoughts, ideas, and sparked some probably a little bit of energy in order to go and learn and develop, and in order to implement that in daily business and daily life. So I wish to thank you for that, Dr. Antonio, for all the speakers that we have now. I'll move now to continue the last 10 minutes in Arabic with Dr. Raed. If you wish to stay, you're welcome. If not, then we understand that you all have a busy schedule as well. Thank you.
Thank you, Mr. Monaf, and thank you all the other speakers for the interesting presentations.
Thank you. Thank you. دكتور رائد، آسف نحن ضلينا للأخير، بس أنا حسيت لما أنت إجاك أكثر من 10 أسئلة أنا قلت حرام نحن نمرقهم كيف ما كان، فهدول لازم هيك نحكي فيهم شوي. وأنا بعرف إحنا كنا متفقين كمان إنه نعمل بول سريع لحتى نعرف كمان شو رأي الناس بموضوع التنظيف. تحب نبلش نطرح الأسئلة على الناس وندخل بعدين بالأسئلة؟
تمام، يلا.
تمام. طيب في سؤال ظهر على الشاشة لدى الجميع. السؤال سؤالين. السؤال الأول بيقول: هل تعتقد أن التنظيف الجاف يمكن أن يكون كافيا لتنظيف الأنظمة الشمسية الكهروضوئية، أم هل تحتاج إلى التنظيف الرطب بالماء؟ بدنا رأيكم أنتم، رأيكم الشخصي. هل يمكن للتنظيف الجاف أن يساعد في الحفاظ على نسبة منخفضة من الأتربة؟ يعني السويلينج ريت إنه دائما يكون محافظ على رقم على نسبة صغيرة. فبدنا نشوف يعني أنتم رأيكم في الموضوع. الموجودين على السوشيال ميديا رجاء تجاوبونا في التعليقات. السؤال الأول، متى بدي أرجع أكرر حتى ناخذ هيك نسبة منيحة من الأجوبة. السؤال الأول إنه هل التنظيف الجاف هو كافي للتنظيف أو لا؟ والسؤال الثاني: هل ممكن التنظيف الجاف يحافظ دائما بشكل مستمر على نسبة منخفضة من الأتربة ولو سويلينج ريت. ننتظر بعض الثواني. بهاي اللحظة ننتهز الفرصة نتشكر الشركات اللي راعت هذا المؤتمر. الراعي الماسي شركة جينكو سولار راح يكون منهم متحدث في جلسة بعد الظهر إن شاء الله، والراعي الذهبي شركة جودوي اللي راح يكون منهم كمان متحدث في الجلسة القادمة نحكي فيها بالتفصيل. طيب راح نوقف البول هلأ بالنسبة إلى الإجابات اللي وصلتنا، وأشارك النسبة عنا على الشاشة تقريبا نص بنص دكتور رائد. يمكن هذا الشيء بيعبر عن
في امل، في
الماركت.
امل.
في امل ها؟ طيب تعليقك على الاجابات دكتور رائد.
يعني هذا في اغلب اللي بكلمهم يعني مجال الاي بي سي او الاوبريشن مينتنس في مشاريع الطاقه الشمسيه دائما عندهم قناعه انه لازم ننظف استخدام المي، والمشكله الاساسيه انه خبرتهم جاي من بنسميه احنا ايفنت كليننج. لو جت محطه يعني موسخه عليها تراب صار لها اشهر، اكيد دراي كليننج حيكون صعب جدا، لازم اعملها ويت كليننج. وما حدا فيهم يعني اللي بقتنع، لو حد بقتنع بالتجربه، الواحد لما يجرب يعمل ديلي دراي كليننج ما بحتاج اوصل لمرحله اني احتاج الويت كليننج 99% من الاوقات. فيعني خبره الكل اللي بيجاوبوا مع احترامي الشديد للجميع تنبع من الايفنت كليننج. روبوتيك كليننج لسه استخدامها محدود، لكن العبره
ماشي ايفنت
بالتجربه،
كليننج انا فهمان
العبره
عليك.
بالارقام اللي حكينا فيها.
تمام
نعم،
انا فهمان عليك شو قصدك بالايفنت كليننج، بس لو توضحها اكثر
الايفنت كليننج بالضبط. الايفنت كليننج انه انا عندي عدد محدود من عمليه تنظيف المحطه بشكل كامل. يعني بالسنه احنا بنحكي بالاردن مثلا بفتره الشتاء في مطر من شهر 11 لشهر 4 5 تقريبا ما في تنظيف مثل المحطه للمطر. لكن خلال فتره الصيف بنعتبر في 5 أو 6 عمليات تنظيف. ايفنت كليننج يعني بتيجي على المحطه تنظفها، بتجيب عمال، تجيب اجهزه مي تنكات واللي هو وتعمل تنظيف. هذا اسمه 1 ايفنت كليننج. خبره الجميع او الغالبيه الخبره تعتبر مبنيه على اساس التنظيف بهذا الشكل. تنظيف بهذا الشكل بتتكلم عن تنظيف محطه اصلا يعني درجه السويلنج فيها زادت عن 10% تقريبا. فاكيد صعب تنظيفه بطريقه جافه، لكن لما انظف بشكل يومي او مره كل يومين او اقصى حد مره كل 3 ايام بشكل دائم ما بحتاج اوصل للحاجه لويت كليننج، وهي العبره من التنظيف الجاف.
تمام يعني نحن بالفعل هيك بصير، يعني انه مثلا بمر صاحب المحطه والمحطه بعد 6 شهور بقول ليه هيك وسخين الالواح نطفوهم. وقتها صعب انه الواحد يستخدم دراي كليننج لانه تراكمت لاشهر
صح.
هذا صح. فبصفي انه بيستخدم ويت كليننج، ولكن اذا كان تنظيف منظم فهو بيكفي. يعني اتوقع دكتور رائد اثنيناتنا اشتغلنا على مشروع من زمان في معان في الاردن. هذا المشروع بتنظف بشكل مستمر بشكل دائم منظم، فما في داعي انه الواحد يستخدم مية فيه حتى لو كان مشروع كبير، حتى لو كان موجود في منطقة صحراوية بكل معنى الكلمة. يعني انه اصعب من هيك environment ما في، يعني في الاردن او في المنطقة العربية بشكل عام يعني.
صحيح. يعني معان مثال اكثر من 60 ميجا المحطه في الخليج، في اكثر من 1 جيجا سويحان، 1.1 جيجا وات دراي كليننج فقط لا غير. اصلا امكانيه تنظفها بويت كليننج يعني مكلفه جدا جدا جدا، هتعرف 2 3 سنت ما بتوفر.
تمام. طيب هلا هيك دخلتنا بالفلوس، وهون كان جاي اول سؤال عندي عن الفلوس. في السيد ماجد الشمري بيسأل هل بيدخل بحسابات انتاج الطاقة وقت بنحسب نحن LCOE موضوع التنظيف عادة؟
المفروض طبعا بيدخل. هلا لما تعمل سيميوليشن لانتاج المحطه بي في سيست، انت يعني الكل بيعمل سويلنج لوس فاليو اسامبشن اللي بيحط 2% 3%. طبعا اي محطه لو تركتها طبيعيا من غير تنظيف، تنظف بفعل العوامل الطبيعيه كندى كمياه المطر وغيرها، السويلنج لوس رح يكون اعلى من 2 3%، ممكن يوصل 6%، ممكن يوصل 10%، ممكن يوصل 20% حسب الموقع. ففي اسامبشن بنحط بالبي في سيس 2 3%، وعشان اوصل للرقم هذا لازم يكون في تنظيف. هلا السؤال طبعا يعني هل في لص؟ في لص. اعتقد السؤال انه على كلفه التنظيف ولا كيف كمان مره؟
يعني انه هل كلفة التنظيف تدخل بالموديلينج عندك، وطبعا الفائدة منه كمان هل بتدخل يعني الاكسترا
كلفه
انرجي؟
التنظيف بتدخل باللايت كوست اوف انرجي، بتدخل بالفاينانشال موديل للمشروع 100%. هلا كلفه التنظيف عشان احددها بدي اعرف انه طريقه التنظيف. هل هي مانيوال كليننج، هل هي دراي كليننج، هل هي ويت كليننج. عدد المرات رح ننظف فيها طبعا، نحتاج انظفها. هاي تدخل طبعا في حساب هاي الكوست اوف كليننج، كلفه التنظيف عباره عن اوبريشن مينتننس ايتم. هذا بدخل بالاوبكس تبع المشروع، زيه زي تكاليف الصيانه، تكاليف الحراسه، تكاليف الانترنت وغيرها. ف100% بتدخل بهذا المجال.
تمام. او ممكن اذا كان مثلا في روبوتات وكذا ممكن تدخل في الكابكس، صح؟ يعني انه يعني
الكابكس الروبوت بدخل بالاثنين، بدخل بالكابكس اذا شريته انت كجزء من اي بي سي، لكن بنفس الوقت له اوبكس. هاي ما ننسى نقطه مهمه، الروبوت مش والله كابكس وخلاص شغلته واستمر، له اوبكس، له كابكس اند اوبكس. وممكن في شركات يعني ممكن تتكلم انه تعطي الكليننج از سيرفيس يكون بيورلي اوبكس، ما يكون جزء من كابكس.
تمام. حتى اتوقع كمان قليل اللي بيضمنوا انه يشتغل 20 سنه او كذا بنفس يعني دوره حياه المحطه. يعني كمان هذا التحدي بنشاف يعني في الماركت، لما الروبوت مضمون 10 سنين بس السيستم يفترض يشتغل 30، فكمان يعني شوي بيكون في مس ماتش.
صح. الروبوت يعني احنا بنحكي فيها دائما بالمايلج. كيف السياره بتحكي سياره عليها 20,000 كيلو قبل اول صيانه، الروبوت بنقاس بالمايلج. يعني كل 1000 2000 متر لازم تغيير عجال، تغيير برش، زي اي فيكل يعني لها صيانه.
طب حلو. طب دكتور رائد، في سؤال هيك تركي، يعني فيه كلمات مفتاحية مهمة من السيد لؤي النجار. بيسأل هل التنظيف نظام الطاقة الشمسية الكهروضوئية بشكل كفؤ بشكل جيد بيأثر على كفاءة الألواح الشمسية المركبة، على الإفشنسي تبع السولار موديول؟
طبعا التنظيف بيأثر من ناحيتين. انت طبعا اول هدف من التنظيف انك تشيل موضوع الغبار اللي موجود، هذا بيرفع الكفاءة، لانه الغبار عبارة عن فلتر للضوء اللي نازل على اللوح اساسا، بيعمل بلوك. هاي الشغلة. والشغله الثانيه بياثر على الكفاءه، نوع التنظيف، وهل بيعمل خدش للكوتينج اللي موجوده على البانل، اللي هي الكوتينج اصلا موجوده على البانل عشان تزيد الترانسميشن للضوء داخل البانل. هذول النقطتين لهم اثر على الكفاءه.
حلو، شكرا لك. طيب في سؤال من السيد فارس زاوي، بيسأل إذا الروبوت رايح جاي كل نهار عم ينظف، هو عم يسوي شيدنج، عم يظلل على الألواح الشمسية، فهل هذا بيأثر عليها؟ ممكن يسبب أعطال، ممكن يسوي هات سبوتس، ممكن يخفض إنتاجية، فقديش ممكن يكون تأثيره؟
هلا في يعني زي عمليه التنظيف لها اوقات وشروط لازم يعني تحققها قبل البدء بهاي العمليه. لما نستعمل روبوتيك كليننج يفضل او المفروض انه ما ننظف في الاوقات اللي فيها هاي راديانس، الاوقات اللي هي ما بين 10 صباحا ل3 عصر، يعني ما في داعي نشغل روبوتس لانه بيعمل شيدنج. الروبوت بيمشي البرش بتكون 100 120 ار بي ام. الروبوت نفسه بيعمل يعني بالدقيقه ما بعرف يعني 10 15 متر، شيء زي هيك. فهو ماشي اكيد رح يعمل شيدنج، لكن احنا بنفضل دائما ان نحرك الروبوتس يا في بدايه النهار او اخر النهار. والافضل عشان اتخطى عمليه ان يكون في ندى على البانلز الفتره الصباحيه، اني انظف اخر النهار. اخر النهار حتى في مناطق الخليج اللي فيها نسبه رطوبه عاليه الالواح تكون ناشفه. يفضل تشغيل الروبوتس على اسقاط تكون الالواح جافه. وثاني شغله تكون فتره العصر راديانس اوطى من 300 واط بير سكوير متر، اذا بتحكيها بارقام يعني بعد الاربعه بعد الخمسه، ممكن الساعه 6 يعني تشغيل الروبوتس. بس اكيد مش هشغله بالنهار، لازم اتاكد الروبوت ما يعمل هوت سبوت على البانل.
تمام 100%. طب بدي اسالك كمان سؤال من السيد عبد الله السهل، بيسال يعني بالبرزنتيشن عندك حكيت عن تقريبا 6% خساره بالانتاج انه اذا ما نظفنا، فهل وحكيت عن شويه ريسكس، يعني مشاكل ممكن تصير عندنا، احتمال تصير عندنا اذا استخدمنا الروبوتات كالخدش او استخدمنا الفراشة المش مناسبه اللي ممكن نحن تخفف من او تاثر على الالواح الشمسيه نفسها. هلا هل معناتها بالمحصلة مو جايب همه التنظيف في المنطقة العربية ولا لا؟ شو رأيك؟
مش قضية يعني. هلا أول شغلة إذا ما نظفنا النظام الشمسي المحطة، نسبة اللوس ممكن تكون 6%، ممكن توصل 30 أو 40%، بس يعني حسب المنطقة. المحطة اللي حكينا فيها 13 ميجا موجودة في منطقة فيها نسبة رطوبة عالية بالصيف، وبالليل الندى اللي بتكوم على البانل بيعمل دروبلتس تشيل التراب. هاي بتصير 20-30 مره، هاي عباره عن ناتشرال ايفنت كليننج بسميها. كنا ما بدي احكي اذا ما نظفنا حنوصل 6%، لا ممكن توصل 20-30% لص. هلا السؤال هي موفيه مش موفيه، كم قيمه ال 20-30% لص؟ هاي شو التعرفه اللي انت بتوفرها من النظام الشمسي؟ يعني حسبه بسيطه. هل الرقم هذا انت كاونر كاوبريتور مش سائل عنه، او السيستم جايب انف سيفنجز توفير والله ما في داعي ادفعها؟ ولو بدي اخفضها ل 2% مثلا او 1% في كلفه، والمقارنه بين اللوست فاليو والكلفه، وهذا الديسيجن يعني ايكونوميكال بسيط.
تمام تمام تمام.
يعني مثال صغير منيف، بالسيستمز المنزليه اغلب الناس ما بتنظف، بتتركها على الروف وبيعمل سيفنجز وبتنظف مره مرتين بالسنه وماشي الحال. هلا هم فاقدين حوالي مش اقل من 10-15% بالحركه هاي، لكن وجع الراس اني احط روبوت اطلع انظف بقول لك يعني
مش مستاهله.
مش مستاهله، وانظمه صغيره بتكون، فيعني هذا يبقى بيورلي تكنو ايكونوميكال ديسيجن يعني.
تمام. واهم شيء ما يمسك نبريج الميه بنص النهار وبرا درجه حراره 40 ومي بارده
لا مستحيل، لانه مايكرو
يشطفهم.
كراكنج حتى بالويت كليننج له شروط، لازم ما تكون
تمام
ديمينرايزد عشان ما تحور البانل، واكيد حراره المي لازم تشابه حراره اللوح، ثيرمال ستريس بتكون ضخم عليها، انت بتنظف لوح ازاز بالاخر يعني.
تمام 100%. طيب سؤال من السيد حسام الدين الصالحي بيقول: هل التنظيف الجاف بيسبب خدوش؟ أي حكيت عنها دكتور رائد. وهل بيسبب مايكرو كراك؟ وهل التنظيف بالماء هو يعني أقل، خلينا نقول، تأثير سلبي على الألواح بشكل عام؟
هلا اي عمليه تنظيف لها انتراكشن مع البانل والها امباكت على البانل. التنظيف الدراي كليننج بيعمل ابريجنج، يعني حتى لو استعملت يعني شعر من خيل، يعني فيري سوفت بريسل بنسميها احنا، راح يكون لها على المدى البعيد نوع من التاثير على الابريجن للكوتنج، هذا بقلل من الكفاءه تبعت الكوتنج اللي على اللوح. احنا بنحاول دائما لما نستعمل روبوت تكون في دراسه وافيه على نوع البرش نفسها، على الامباكت عليها، ولازم في شهادات من الموديولز او ثيرد بارتي تيستينج تعطي معلومات عن التاثير هذا. هلا بدي ارجع احكي انه حتى الويت كليننج اذا ما انعمل صح بيعمل مشاكل للوح. هلا مايكرو كراكنج بيصير في حاله الميكانيكال لودينج، سواء عملت دراي كليننج ولا ويت كليننج وحملت اللوح يعني اوزان مش يعني بمواقع معينه وغير مواقع اخرى، عملت انت يعني لوكال ستريس على الميكانيكال ستراكشر للوح، فبالتالي هذا بيؤدي للمايكرو كراكنج. لكن التنظيف حد ذاته ما بيعمل مايكرو كراكنج، بس اي نوع تنظيف دراي او ويت ممكن يعمل مشاكل اذا ما انعمل صح للبانل. يعني حط مي بارده على اللوح بعز النهار، هذا بيعمل مايكرو كراكنج، انه في ثيرمال ستريس ميكانيكال ستريس. وبدي احكي شغله كمان، يعني موضوع انه والله احنا لانه بصير ابريجن مش لازم نعمل دراي كليننج. الابريجن حاصل على يعني تحط بانل يعني بيصير في حركه غبار.
دكتور رائد، أنا فقدت الصوت. ما بعرف إذا الباقي الموجودين معنا سامعين صوتي بشكل واضح. رجاء الكتابة بالتعليقات إذا كنتم سامعين صوتي بشكل واضح مسموع. طيب شكرا. ما تعلق متى المشكلة عند الدكتور رائد يفترض نعطيه بضع ثواني. إذا رجعنا فنحن بنكمل بالأسئلة. بهاي الأثناء أنا راح أرجع أذكر إنه نحن حنوقف هلأ ببريك لمدة ساعة تقريبا. حنرجع نبتدي على الساعة 51 دقيقة بتوقيت مكة المكرمة. حيكون عندنا مجموعة جدا مهمة من المواضيع. رح نحكي فيها عن الشبكات الكهربائية، رح نحكي فيها عن بعض الحلول الموجودة عندنا بالمايكرو جريد وأنظمة تخزين الطاقة وأنظمة الهايبرد. كثير ناس تحكي عن الهايبرد وبتحكي ما عندنا مصدر جيد للمعلومة عن موضوع الهايبرد. رح نحكي عن الهايبرد، أنظمة الهايبرد كيف بنعملها تصميم كديزاين. رح نحكي عن أنظمة الهايبرد كيف إحنا نختار المكونات لما بروكيورمنت بدنا نشتري مكونات لأنظمة الهايبرد، فنحن شو نخلي إحنا عنا في بالنا وقت اللي بنسوي هذا الموضوع. مواضيع جدا ضرورية للأشخاص اللي شغالين في موضوع المايكرو جريدز، في موضوع الهايبرد، لا يتعلموا أكثر عن هذا الموضوع. بدي أرجع أتشكر أن رعاة المؤتمر الراعي الماسي شركة جينكو سولر اللي دائما موجودة معنا في أهم المؤتمرات المؤتمرات بالنسبة لموضوع الطاقة المتجددة، وفريق دائما نشط في هذا الموضوع. راح يكون معنا اليوم بعد الظهر المهندس حمزة مرة ثانية اليوم، مشكورين لتواجده معنا. والراعي الذهبي شركة جودوي اللي راح يكون معنا المهندس فادي مقدسي بالنصف الثاني من اليوم، راح يحكي عن التقنيات اللي بتقدمها شركة جودوي، حتكون موجودة معنا في النصف الثاني بعد ساعة تقريبا إن شاء الله. طبعا الأسئلة الباقي الموجودة حنشوف طريقة نجاوبكم فيها بأسلوب آخر، كونه انقطع الإنترنت الاتصال مع الدكتور رائد. نحن رح نوقف هون. الموجودين على زوم تقدروا تبقوا معنا على زوم وتاخذوا البريك وتخلوا الزوم بيشتغل، ما في داعي تطلعوا. الموجودين على السوشيال ميديا نحن رح نوقف البث ورح نكمل البث إن شاء الله. نعيد البث مرة تانية على الساعة 1:50 بتوقيت مكة المكرمة، رح يبلش بث جديد على صفحاتنا. فبهذا الأسلوب نحن إن شاء الله بنكون قادرين على إنه نكمل الجلسات المخطط لها. أنا شايف هلأ بيدخل الدكتور رائد، إذا بقدر يكمل معنا بكون ممتاز. بنلحق لنا كمان سؤالين. خلونا نجرب.
نعم
بكون حظ.
معك.
قطع الاتصال. أنت سامعني كويس دكتور رائد؟
نعم سامعك.
لأنه صوتك عم يقطع للصراحة. رح أجرب إني أسألك سؤال كمان لو سمحت من الأسئلة الموجودة لسه عنا، ممكن؟
نعم تفضل.
إيه طيب. أنا في سؤال صراحة أنا أول مرة يعني بمر علي هذا السؤال من السيدة أتوقع فاتحة حميدة، بتسأل: هل عملية التنظيف الدائم اليومي لا يترتب عليها أعراض جسدية على العنصر الجسدي مثل السرطان والأمراض الجلدية؟ يعني الشخص اللي بينظف الألواح الشمسية أو بيشتغل مع الألواح الشمسية بشكل مستمر، هل ممكن يتعرض لأمراض معينة؟ هل في أي دراسات بالنسبة لهذا الموضوع؟
ما في أي شيء معين، يعني ما في أي راديشن بيطلع من البانلز يعني ممكن يعمل أي أنواع أمراض. يعني مجرد إنه لازم أي أوبريتور طبعا يكون عنده البي بيز والسيفتي اكويبمنت صحيحة وعمل خارج فقط لا غير. ما في أي أمراض ممكن تترتب.
حلو. وسؤال تاني كمان إجانا شوي هيك، في عندي كم سؤال يعني حلوين أفكارهم، أول مرة بينطرحوا معنا. السؤال من السيد سعد علني، بيسأل: ليس أفضل المحافظة على نظافة الألواح الشمسية وأنه نقلل التنظيف بحيث أنه نزرع الأرض الموجودة تحت الألواح الشمسية؟ هل هذا الشيء كمان أسلوب ممكن يساعدنا على أنه نخفض السويلينج؟
هلا موضوع الفيجيتيشن، الفيجيتيشن طبعا التراب اللي بيسقط على الالواح مش جاي من منطقه المشروع نفسه. انت بتحكي على غبار محمل بالرياح، يعني تحمل التراب من منطقه الى منطقه. لكن عموما تحت البانلز ما راح تساعد. يعني عاده احنا بنشيل النباتات اللي بتنمو تحت البانل اذا كان في غرض زراعي منها. لكن عموما إذا كان هناك إمكانية يعني بناء سواتر ترابية نسميها، مثلا الفنس تبع المحطة بنحط عليه زي كلوث أو شيء يستر يمنع التراب اللي هو وزنه ثقيل، اللي هو يكون البارتيكل حجم أكبر من 100 مايكرون إنها تمر داخل المشروع. هذا ممكن يساعد. لكن الفيجيتيشن تحت البانلز نفسه ما راح ياثر. لكن خارجيا نحاول ان تكون المنطقه مخضره او في ساتر ترابي جزء من الفنس بيمنع التراب اللي هو ارتفاعه مش مرتفع، اللي على ارتفاع متر مترين، ممكن يساعد بهاي العمليه.
تمام. طب سؤال كمان لو سمحت دكتور رائد، عن موضوع الوزن تبع الروبوت. بيسأله سيد بسام تقي انه هل ممكن الوزن تبع الروبوت يأثر على اللوح الشمسي يعني بسبب الضغط عليه يعني؟ دكتور رائد ما بعرف اذا سمعتني.
اكيد الروبوتس هلا الموجوده بالسوق وزنها بتتراوح ما بين ال 30 وال 40. نعم سامعني منير؟
ايوه سامعك. ايوه
هلا الروبوت نفسه وزنه بتراوح ما بين 30 كيلو، بعض الروبوت بوصل ل 120 ل 150 كيلو جرام. فاكيد ممكن يكون له تاثير على التراكنج. عشان هيك يعني موضوع اذا كان الروبوت بيمشي على الفريم نفسه للوح، الوزن شيء مهم جدا. يعني اذا كان وزن الروبوت اكثر من 50 كيلو بعتقد هذا شيء سلبي، لانه انت بتحكي على تنظيف يومي او شبه يومي ودايناميك لودينج على الدائم على البانلز. فهي نقطه لازم الاهتمام فيها.
تمام. طيب هيك اتوقع دكتور رائد نحن خلصنا اجابه على معظم الاسئله اللي وصلتنا نحن بالنسبه لهذا الموضوع. بتشكرك كثير على وقتك، واسف اخذنا اكثر من الوقت اللي خلينا نقول اللي خططنا له. تاخرنا نحن تقريبا ربع ساعه هلا عن موعد انتهاء هاي الجلسه. بس دكتور رائد يعني الجزء اللي حكيت فيه يعني ولد كتير أسئلة مثل ما شفت. الحمد لله أنه قدرنا نجاوب عليها، وشكرا لأنك رديت رجعت على الجلسة وكملتها معنا اليوم. يعطيك ألف عافية. بدي أتشكرك كتير. نحن رح ناخذ هلأ بريك كلياتنا تقريبا 50 دقيقة رح يكون، ورح نرجع على الساعة 1:50 لحتى نكمل بالقسم الأخير من هذا المؤتمر، ونحكي فيه بالمواضيع اللي خبرتكم عنها من شوي، عن موضوع الهايبريد سيستمز وعن المايكرو جريدز، نحكي فيها بتفصيل أكثر. بدي أتشكرك دكتور رائد، إذا بتحب تقول شيء آخر شيء. طيب بالنسبة للحضور لكن
شكرا جزيلا.
شكرا لك.
يعطيكم العافيه. بالعكس اسف على الكونكشن، وان شاء الله يكون كان فائده من النقاش. شكرا جزيلا.
تمام، شكرا كثير لك دكتور رائد. لكن نحن حناخذ بريك صغير، نوقف البرودكاست على السوشيال ميديا، ونرجع بالبرودكاست مرة تانية على الساعة 1:50 بتوقيت مكة المكرمة. إن شاء الله نلقاكم قريبا.